Uno. Adelante, David.
Hola, ¿qué tal? ¿Cómo están? Muy buenos días y bienvenidos a movernos en este proceloso mundo virtual. De parte de todo el equipo organizador, les deseamos que este día sea aún más interesante y que les traiga más satisfacciones que el día de ayer. Les recordamos que pueden navegar dentro de este sitio, donde van a poder encontrar el apartado de los carteles, para poder conocer los excelentes trabajos que se han presentado y bueno, también pueden inscribirse a nuestro próximo curso, que es el uso de la tecnología dron en el monitoreo de manglares. Les recordamos también que durante las conferencias y las ponencias, en caso de que se detenga la transmisión, solo hay que refrescar la pantalla para que también así puedan ustedes continuar disfrutando de todo el contenido que hemos preparado con mucho cariño para ustedes. También no olviden que del lado derecho de la pantalla encontrarán el chat. Ahí van a poder comentar acerca del Congreso. Y en el apartado de las preguntas al ponente van a poder escribir todas las dudas que tengan para cualquiera de los ponentes y para cualquiera de las temáticas que estamos exponiendo. Y bueno, estas van a ser respondidas por nuestros expertos moderadores cuando que se van a resolver al aire, ¿no? Bueno, para el día de hoy, miércoles 28 de octubre, tendremos las siguientes actividades. A las 9 de la mañana, de 9 a 10 de la mañana, vamos a tener la mesa de servicios ecosistémicos, moderada por el doctor Carlos Buruelo Ramos. Y también tendremos a las 10 de la mañana la conferencia magistral por el PhD John Boone Krugman, de la Universidad del Estado de Oregón, con el tema Ecosystem Values and Traits of Latin American Mangroves and Beyond. A la 1 de la tarde, de 1 a 2 de la tarde, vamos a tener la conferencia magistral con el doctor Ezequiel Escurra, de la Universidad de California, con el tema ¿Qué nos dicen los manglares sobre el ascenso del nivel de mar? A las 11:15, más o menos, de 11:15 a 12:15, vamos a tener la mesa Conservación y Manejo, moderada por el doctor Carlos Burello Ramos. Y en el turno vespertino, a las 4 de la tarde, vamos a tener la conferencia magistral con la doctora Maribel Domínguez del Colegio de Postgraduados, que va a exponer acerca de las características del manejo forestal de los manglares de Tabasco, México. A las 5:15, de 5 a 7:15, vamos a tener la mesa con el título Conservación y Manejo, moderada por el doctor Ederardo Barba Macías. Bueno, pues muy bien. Por último, vamos a querer invitarlos a que descarguen la aplicación del Congreso, del evento, y es muy sencillo. Solo tienen que ir a las tiendas Google Play Store o App Store y buscar la aplicación con el nombre Event Box. La descargan y así van a poder acceder a todo el contenido y a todo con el mismo correo y contraseña con el que se han inscrito al Congreso. Bien, pues les deseamos un excelente día y que sigan disfrutando de este maravilloso Congreso. Esperemos que estén muy bien en casa, disfruten mucho el día y nos vemos. Muchas gracias.
Good morning, everyone. Good morning to all the attendees to this roundtable on ecosystemic services. We're going to be having 4 presentations in this table, and we're going to begin with our first presentation, which is entitled Pre-Hispanic Burials and its Relationship with the Ecosystemic Services of Mangroves at El Conchalito in Baja California Sur, Mexico, as a case study presented by Dr. Giovanni Avila and Miriam Areli. You have the floor now, Giovanni. You have 10 minutes for the presentation, and later we'll have some time for questions that the audience will be sending. We ask all the participants to please send your questions timely so we have enough time to make it the question to the presenter. Thank you for the introduction and for the technical team that make this possible. Can you see my screen now? Very well. We'll start by giving a definition of the ecosystemic services. There are so many in literature, but we could say that these are the benefits of nature for people. There are different kinds of ecosystemic services. There's like a classification of 4: provisioning, maintenance, regulation, and the cultural ones. And I would like to focus on those. We're observing this image of the Balandra mangrove in Baja California Sur. And we can observe that this aesthetic beauty produces pleasure, it produces well-being. And unfortunately, due to this quarantine, we have lost access to this kind of ecosystemic services. Another kind of cultural service might be fishing as a recreational activity, also the use of ecotourism, different activities, family activities around the beaches, and it's also like a symbol for the local identity. In this chart that we can observe in the screen from Bryce et al., we can observe how the different cultural activities are based on the environmental attribute in the landscape, and at the same time, these leads to ecosystemic benefits. In this image, in this table by Holaland, we can observe 3 types of classification when it comes to the services. You can even find 10 different types here on the first column. Then we have 5 different ecosystemic services, and the CISES has 4 different classifications. When it comes to ecosystemic services in Baja California Sur, the research has focused on the relationship between tourism and the protected areas. This has been performed by Hernández Trejo and Urciaga and Lauterio Martinez. We find that there are fisheries that have been studied by Aburto in Baja California. We have $37,000 per hectare, and also we have been studying carbon by Escurra and Adame and Ochoa Gomez in 2019. Likewise, besides their traditional uses that we may consider in the mangrove, some of them are not so well known, but they are still important, like the honey production that happens in the Gulf of Mexico, the structure for housing, and also for rituals. The bibliography for mangroves, we have quite a lot. In the case of Baja California and Baja California Sur, there are some studies, but we do not have so many when it comes to ecosystemic services as such. Through these analysis, we know that in the peninsula of Baja California, the presence of humans goes back to 12,000 years ago. in the Neocene era, and the population were exploiting the resources during these times. They were described by Jesuits and historians as tall men and women with long dark hair, and they used different pearls and things on their hair that made some sounds, particular sounds. Men and women were great hunters and collectors. They were quite resilient to the climate, and they were also good divers and fishermen. There are many sites that we have found throughout the peninsula of Baja California, and we have seen many cultural activities. We have seen places where they used to cook and find food, and some burial sites. We have El Conchalito, which is called like that because of the mangrove that has the same name, and it's on a side of this site. This use goes back to 5,000 years ago and up to before the Spaniards came. We have found many species of shellfish, and they are associated also to the rituals of those inhabitants. This identification of the shellfish indicate that their extraction came directly from the mangrove area. The information of the exploitation of these resources on the south of the peninsula is supported by many archaeological analyses, like the one from Jarome Saquita, Leticia Gonzalez, Alfonso Rosales, all of them from the National Anthropology Institute of Baja California Sur, and we have the chronicles of the Jesuits and the historians. The goals for this work is to estimate the ecosystemic services offered by the mangrove during these pre-Hispanic times, and we have to determine the role of the mangrove with the burials that took place there, and also to link the connection of these species that were associated to the systemic services. The area of study can be found within the city of La Paz in Baja California Sur, surrounded by a Ramsar site of Humedales Mogote in Ensenada, La Paz. We find these species, Avicennia, and many others. The methodology for this study is done through a qualitative research design. We use this data triangulation. Triangulation means that we are using different quantitative and qualitative data sources, theories, researchers, and the study of a phenomenon. We also consider the classification of ecosystemic services from species. This systematic review that we perform is considering the information from the library of the Autonomous University of Baja California Sur and from CIVNOR and CICIMAR. We have the keywords or filters, and we found information from the year 1535, and we also use the word El Conchalito for our search, and we reviewed the historical archive of Baja California Sur. According to the literature, we found a lot of remains of wildlife. We could find a lot of shellfish, and they found these species that are on the table, like Turbo fluctuoso, and many other species. And the analysis tells us that they consume a lot of shellfish for feeding, and we can see that they have been burned. That means that they cooked these shellfish. And other remains tell us that they used also other species as spears for fishing, and they also used these shells for making other sorts of tools. The main source of resources came from the mangrove, and that is clear. Considering the type of use that they had for these shellfish, we relate this to the CSIS table. In this case, they were considering 20 types of ecosystemic services, and we are comparing the use that the population gave to these resources. We have the partial results now of our study, and we can say that the indigenous peoples used 4 types of ecosystemic services through the provision of nutrients as food, as materials. On a cultural aspect, they used it as heritage, as culture, and also in a religious and spiritual way. Finally, I would like to thank the different institutions that contributed to our work: the Autonomous University of Baja California Sur, the Natural History Museum, where I'm studying my postgraduate, the Ecosystem Services Partnership, and the Diploma on Cultural Heritage, Definitions, Debates, and Challenges. And this methodological proposal is part of my work, so I could find and finalize this study. Thank you. Thank you, Giovanni. We don't have time for questions. We're gonna have your presentation available in the platform for a couple of days, and we'll receive the questions through there, and we will send it to you. Continuing with the agenda, we have now the presentation of Emilio Romero and Ernesto Velázquez with the topic Assessment of the Biotic Integration in River Mangrove Systems Using Fish as Indicator Groups. Good morning. Hello, good morning. Please, you may begin your presentation, Emilio. 10 minutes if you want to have some time for questions. I will try to be as brief as possible because this is an extensive work that we are doing and we are still polishing it with time. Before I begin, I would like to put ourselves into context. I'm going to be talking about these tools that I am using. As we know, the mangrove systems are environments of high ecological complexity. This has always been an aspect that becomes a great challenge for its handling, especially when it comes to the assessment and monitoring. Well, assessing the quality and the integrity of these ecosystems, sometimes they seem to be like opposite concepts. The Biotic Integrity Index do not attempt to replace other methodologies used for assessing the mangrove quality, like nutrient measurements or sediments or the water quality or the complexity of the vegetation. This is the capacity of an ecosystem to support a community of organisms through a diversity and functional organization with a reference to a habitat or a region. It is really difficult to find a habitat with these characteristics, but we always look for the trends to the less impacted regions. And well, an index of this sort is aiming to find attributes of a community within a multi-metric index and to infer the level of impact that an ecosystem is presenting. Like I said a moment ago, It's not like trying to replace another kind of tool. What we want to do is to complement that tool and using a paradigmatic group, which is the mangrove fish. Mangroves are considered as the core for the maintenance of the fishing resources. Furthermore, an index of this kind also enables to establish a co-management strategy with the communities because they know their own fishing resources, and from the species that we have in the mangroves, we can infer the level of integrity of the whole ecosystem. In general terms, that would be our main hypothesis for the use of a tool of this kind. How did we do this? Well, basically, in order to develop a monitoring tool like this one, we have to build them with a solid baseline based on the ecological structure of the communities that we are assessing, considering spatial and time patterns. And within the scope for having an efficient ecosystemic handling, we have to highlight knowing the local ecological processes as well as the regional ones, the differential influence of the diversity scales, alpha and beta, and to define and measure the biotic integrity. On a level of the Pacific, in Mexico, there are some coastal regions identified with great potential for developing environmental indicators. Most of them are in the California Gulf, but also in the Tehuantepec Gulf in the Pacific, in the South Pacific, is also important because there are many lagoon and coastal ecosystems surrounded by mangroves. So this is a good place for developing these kinds of tools. The goal was to analyze the ectic communities associated to the river systems of the mangrove in the Gulf of Tehuantepec in the state of Chiapas in function to the taxonomic composition structure and patterns of local and regional variation with the purpose of having a multimetric tool for assessing integrity. We have been sampling in a systematic way between 2013 to 2018 in 64 different stations distributed in these mangrove areas in the Gulf of Tehuantepec. And we had the challenge, many challenges during the sampling, because even if they seem homogeneous environments, we have different habitats with different geomorphical characteristics that have differences. We have different lagoons and channels, and we have also different sorts of mangroves, Abyssinia, and also river mangroves that are like shrubs and arboreal mangroves. And this involves more complexity. And also we have to standardize the sampling method, and that's complicated. We tried different fishing types. We use these nets and these barriers in order to take the samples. We have to consider environmental parameters, temperature, salinity, dissolved oxygen, pH, conductivity, and also we focus on the structure of the habitat and the microhabitat with the potential to have nursery grounds, maybe the density, the size of the roots, the thickness of the roots, etc. And this led to determine that there are similarities and differences in the composition of species that we can find in each type of mangrove, whether it's physiographic or geomorphical. It is also necessary to consider that they will have differences in the dominance. We are going to have residing species throughout the year. Other species are temporary, occasional, and we have different proportions. When it comes to the length, it's also variable. There are some habitats that will have animals of a smaller size and others with a larger size. So we mainly worked in the river mangroves that have a permanent water body, and they also have more diversity when it comes to the populational properties. And this has helped us through several techniques to differentiate between the different habitats according to the features. Another important aspect has been to consider the scale. What is the application scale of an index like this one? For mangroves, we have regionalized. We have here the one by Robertson and Kramer, identifying co-regions in the Pacific, and more recent ones like Castellanos and Galindo that speak about two different regions. The Cortesian, which is in the Gulf of the Tehuantepec and the tropical area, and all the way to the north of Peru. But due to the characteristics and the differences between these characteristics in the Pacific line, we consider that it is possible to distinguish ecoregions within these global regions. In order to verify this, we made a large database of presence and absence in order to identify some of these ecoregions. In the case of the mangroves in Chiapas, Nicaragua, we have like an homogeneous region, unlike the region of the Gulf of California, for instance, or in Central Pacific, in the north of South America and Central America. To be more thorough in this analysis, we assessed this similarity within the Gulf of the Tehuantepec on a smaller scale. And within that Gulf, we were able to identify two different regions. In the south, we have El Soconusco, which is more humid with more rivers, and the closer one to the northern Istmo with hypersalinity conditions. Well, this is information regarding diversity. The alpha diversity is higher than in the north of the Istmo. This is a multivariate analysis that allows to identify these differences, and this is the result on the variation within the community and within these regions. We also consider these trophic ranges, and we integrated all of this information, and we selected the most diverse system, which is our reference system for developing a tool. This is the lagoon system, Chantuto Panzacola. In order to calibrate our indicator, we developed a preliminary environmental quality index, considering criteria proposed by Vasconcelos: water quality, use of soil, and fishing activity. Here we mentioned the description per type. Some of the metrics that we selected were this, based on systems that are used in coastal regions and the methodologies that we decided to use. And as a preliminary result, we can say that we were able to differentiate impacted area from controlled areas based on our preliminary index. And from all the metrics that we obtained through the fish, we selected 10 metrics by eliminating redundancies. We got to 10 metrics that perhaps can indicate the integrity of these ecosystems based on the selected sites within this system. We were able to classify them preliminarily in 4 different scales, with a poor condition, good condition, regular, and excellent condition. By making a regression and understanding the calibration of the index, we obtained an acceptable relationship. And the map would look like this. We were able to differentiate environments with a higher level of integrity and lower integrity. And well, I have to mention that this is a preliminary result. We still need like 30% of the calibration of the index. We need to implement other techniques and we need to include other experts to have a better calibration of an index like this one. However, the index discriminated quite well the sites with different levels of impact. And well, that would be all. Thank you. Thank you for your presentation. We do not have time for questions. But well, if we have any, we will send it to you. Now, continuing with the program, we have the presentation by María del Carmen Martínez García and Ana Laura Lara Domínguez. They will be talking about the structure of the mangroves associated to the estuary of Jacome de Tuxpan, Veracruz, and the perception of the value of the ecosystemic services. Thank you. Good morning, and we are going to continue with the agenda now. We have the presentation structure of the mangroves associated to the estuary of Jacome de Tuxpan, Veracruz, and the perception of the value of the ecosystemic services. Presented by María del Carmen Martínez García and Ana Laura Lara Domínguez. Please, you may begin with the presentation. And thank you. Hello, good morning. I'm going to show you the video of my presentation, and I hope you like it. Hola, ¿me escuchan? Es que creo que la presentación la están pasando por otro lado y yo no la puedo ver.
Lo importante es que al noroeste colinda con propiedades de la administración portuaria. Para este trabajo, el polígono de Manglares se dividió en 3 zonas de interés. La zona 1 la llamamos Jacome, la zona 2 la llamamos Marinos y la zona 3 la llamamos tal cual TPT. Para determinar la estructura forestal se utilizó el método de cuadrante al punto central, PCQM por sus siglas en inglés. Se establecieron un total de 12 transectos distribuidos en las 3 zonas de interés que se mencionaron anteriormente, en los cuales los transectos tenían una longitud de 100 metros y cada 10 metros iban haciendo las lecturas. Las variables obtenidas en campo fueron el diámetro, la altura del pecho, la
The
altura.
variables that we obtained was the diameter, the length, and the distance between each one of the quadrants. We use this analysis, the structural analysis. We use mangrove structure for this study, and this allowed us to get the relative values of the density, the frequency that are useful values when describing the mangrove communities. The variation of the ecosystemic services was obtained through the application of a survey with a dichotomic response and focused on the assessment of the services, and this was obtained in this manner, and for that they applied this in 4 different localities, too close to the estuary and 2 that were not that close. We had the participation of men and women of age, and they needed to be performing an activity. We ran a qualitative and quantitative analysis, and for the quantitative analysis we used the different tests to see if there were similarities between the localities. The sample size was 208 households that were surveyed. The results of the forestry structure tells us that there are 2 physiognomical types in these mangroves near to the estuary of Jacome. In the area closest to the river, we find this border type of mangrove, and we can see more like basin type mangroves. Zone 1 showed a higher density with 920 trees per hectare, dominated by Rhizophora, and also Racimosa was found in the basal area. It is important to highlight that in this zone of the transect, we were unable to analyze this correctly, and then we moved to zone 2, which is dominated by Avicennia with 186 trees per hectare. And in this zone, we must highlight that we found 4 different species of mangrove. We found 4 of them, and this region had the largest basal area with 11.53 square meters per hectare. In zone 3, we find a more mature forest. The distance between one tree to the other, sometimes it's 7 meters, but the basal area or the DAP were larger. Avicennia hermina showed the highest value with 4.43 square meters, and this matches the results by Jorge Lopez Portillo's study, because he's working really close to this transect with regard of Avicennia hermina. As we can observe in this next table, the maximum values can be found in zone 3, which is the area closest to the port, and these values in average can speak of the structure of the mangroves, we can see that in this zone 1 of Jacome, we have smaller mangroves with smaller diameters if we compare them to the other zones. So perhaps this is a younger mangrove and it has freshwater systems. If we get farther away, we find, well, the whole estuary is a mixed forest, and in most of the transects we find 3 to 4 different species. The average height of the canopy was the one that I'm showing here on the table. However, we started moving around the different zones. In zone 2 and zone 3, we have taller trees. And we find no significant relationship between the difference in the height. The relative values of the density, the frequency, and the coverage determine that Rhizophora mangre got the highest values with 179.3 points, and the zone 1 of Jacome also got the highest values. As a result of the social perception assessment, we saw the participation of 42% of women and 58% of men. The age range went between 18 and 89 years of age. 32% of the men know and have performed activities within the estuary. Some of these activities are fishing, river fishing, and ecotouristic activities. Likewise, only 8.9% of the women know this area. Most of the women used to be housewives, and they didn't really know this estuary, and they had never visited the mangroves in Jacome. They knew about other mangroves, but not these ones. We found some differences between the knowledge that men and women have about these ecosystemic services. So gender had an influence on the answers. And we also found differences between the productivity per locality. We could see the production activities by locality, and these activities can be divided in tourism, fishing, farming, and some of them were entrepreneurs and traders. And when we talked about fishing, many of them said that they had to do several activities because fishing, it's not actually a good economic activity for them. The most valued service by the inhabitants is for the flora, for the wildlife, and this value is an estimated average based on the scale that goes from 0 to 10, because this talks about how important these activities are for them. And when it comes to recreational use, it was also significant when we did the assessment. And we must highlight that in the case of wood, people said that they knew that it was important, but they recognized that it was forbidden, and that it could lead to legal issues if they used the wood of the mangroves. And for the support of the fisheries, it is also quite valued by the fishermen and by the trading sector. We got to the conclusion that these mangroves close to the estuary are a well-structured type of mangrove due to the structure and social perception, and they can be used for developing a good plan in the area because they do not have a good handling plan in the area. So they can consider social, economic, and cultural aspects of this mangrove polygon. And we also got to the conclusion that there's not enough data on the structure of this zone, and all of this information complements and leads to new knowledge that can be used by the sector, and in order to have further considerations on how to handle them. Thank you for your attention. Thank you very much for that presentation. We are going to continue. We do not have time for questions, and we'll carry on with the next presentation. Good morning once again, and to finalize this panel, we have Gustavo Marín Cruz, we have Maribel Domínguez Domínguez, Pablo Martínez Surimendi, César Jesús Vázquez Navarrete. With the work carbon stock on the side of the mangroves in Paraíso, Tabasco. Gustavo, you have the floor now. Good morning, everyone.
Son humedales costeros que ocupan un lugar muy privilegiado por su riqueza natural y los servicios ambientales que nos prestan, su importancia ecológica y así como esta importancia han sido reconocidos a nivel internacional. Los manglares son bosques conformados por árboles por su habilidad para crecer a lo largo de los litorales. Poseen esos mecanismos que permiten eliminar el
These
exceso de sal
mechanisms
y
allow to
tolerancia
eliminate the excess of salt and these tolerance to these waterlogged sites. And in this case, speaking in particular in this site of La Solución Somos Todos, we can mention the red mangrove, the Rhizophora mangle, Laguncularia racemosa, and Avicennia germinas. In Mexico, in 2015, we had more than 775,000 hectares of mangrove distributed along the coastline within the country, and we lost around 81,000 hectares in 25 years. So this decay contributed significantly in the emission of greenhouse gases. Tabasco occupies a broad extension of mangroves according to the monitoring system that CONAVIO has established. Until 2015, we have 45,410 hectares distributed on the coastline bordering the lagoons that are extending on the coastline, and the existing mangrove species in the state are Rhizophora mangle, Avicennia germina, Conucarpus erectus, the 4 different species, and this last one in less extension, but it is equally important. So the ecological importance resides in the functions that it plays for the stabilization and protection of the coastline, giving a nursery ground for food, for different fish species, shellfish, and habitat for mollusks, for crabs, and for nesting of different kinds of coastal birds, as we can see in the image. The direct benefits that the mangrove provides and that we can use and take from this ecosystem, these direct benefits can be extractive, where we consider the use of wood, these different types of woods, and also plants, flowers that are developed and that are growing within the ecosystem. Likewise, fishing, where the surrounding communities get a benefit. The landowners of UMA and La Solución Somos Todos get the benefit of these extractive and provisioning benefit for them. But at the same time, we have the non-extractive benefit, which is more about visiting the mangroves and appreciating the beauty that the ecosystem brings. We can have fun through recreational activities with the family and just admiring the ecosystem and the birds nesting in these trees on the mangroves, and we can enjoy with our own families. The indirect benefits, we can mention sediment retention, erosion control, filtration, fixation of nitrogen, production of nutrients, and storage of carbon. But at the same time, mangroves, in most cases, come with many issues as well. They suffer from deterioration in the vegetation due to natural factors, but also human factors. Just to mention a few, urban development in certain regions of the country. We observe hotel development, also oil spillages that can happen in these mangrove sites. And throughout time, we have recorded them, and they have caused damage on the trees and the wildlife surrounding the area, and this enables a change in the use of soil, reducing the extension of the mangrove, of the vegetation, and the services that can be obtained. The results of these anthropogenic activities, the excessive use of cars, industries, and plastic burning, lead to greenhouse gases, carbon dioxide, which is the one that we are discussing now. And in this context, with the purpose of generating information that might help the landowners of the site and society in general for decision making and awareness on the importance of this ecosystem, we had the goal of quantifying the carbon stocked in the aerial biomass of 3 different mangrove species through allometric models, and to determine the site index of the 3 different species of mangrove. The study was developed in UMA. It's a unit for the conservation, handling, and use of wildlife. It is known as La Solución Somos Todos. It's part of the site in El Paraíso, Tabasco. As you can see in the map, it is close to the Mecuacan Lagoon, and we can observe the oil fields. These fields are key for the modification of the soil and the vegetation. UMA has a coverage of around 1,700 hectares of mangrove in 8 different areas that were established based on the coordinates that we had. Each area has 3 different plots, so we have 24 plots in total. In order to measure the diameter of the trunk was taken from 1.3 meters from the ground for Lagoncularia racemosa and Avicennia. And for other trees, we measure the normal diameter 30.3 meters above the root. That's for Rhizophora. And for the estimation of the biomass, we used allometric equations used for estimating the biomass based on the diameter. Here we can observe the allometric equations that were used per species in function to the diameter. The estimation for the stored carbon and for the obtaining of this carbon, we use the conversion factor of 0.46 for the 3 different species. This was a study by Mordillarzo in 2009 and Kaufman in 2013. With this equation, you can estimate the carbon. It's the estimated carbon contained in the forest, the average biomass per hectare by the conversion factor, which is 0.46, by the total area of the forest. The site index determined the productive capacity of a specific site for a particular species. That is why we estimated the dominant height based on the thicker trees per species in each plot. And also, the site index was determined through the corresponding adjustment parameters and the total height of the tree. As a result, we can say that we have a tree density that presents the species of Avicennia germinans that presented more biomass in average and a higher density with 1,700 trees per hectare with a diameter higher than 60 centimeters. Then we have other species that have lower diameters, lower than 20 centimeters, and on the area number 2, we had the lowest density of trees, and area number 6 with 66 trees per hectare with diameters that are above 60 centimeters. we consider the considerable amounts of aerial biomass on the area 2 and area 6. In the area 3 of the Lavonculera racemosa species, we presented less density in the different sites with 200 trees per hectare, so we have a lower biomass of 3 grams per hectare, because it is surrounding the main lagoon where Rhizophora mangle can be found. The areas that presented the higher biomass were area 1, with a density of 14,000 trees per hectare, followed by site 8 with 17,000 trees per hectare, and area 2 with well, you can see on the table, although the density of Avicennia hermina is lower than the other species, this presented a higher average biomass with 67 micrograms in the different sites. This is due to the existence of trees with higher diameters, followed by Lavonculera racemosa. These species presented a higher density of trees with an important population of trees with less than 20 centimeters of diameter, so it presented a lower aerial biomass if we compare it to Avicennia. The species Rhizophora mangle presented a lower amount of biomass, and we are talking about a border type of mangrove that is distributed along the lagoon. The species with the highest content of carbon in average in aerial biomass was Avicennia hermina, with 31 megagrams of carbon per hectare, being an expected behavior because this species had a lower density in the 8 different sites. However, the diameters were superior to Lavonculera racemosa and Rhizophora mangle. And based on the obtained results, the species of mangrove that stores more carbon, it's Avicennia hermina with 47%, followed by Lavonculera racemosa with 28.76% and Rhizophora mangle with 24%. Taking into account that UMA is presenting a surface of 17,000 hectares of mangrove, we estimated that the total aerial biomass was of 245,314 megagrams, which is equivalent to 113,826. In order to determine the site index in the mangroves, UMA, in the solution, we found these dominant results because we have these mangrove species that have a good productivity in these inventoried sites. We define the classes based on the different index of the sites and type of the mangroves of Tabasco, and the index of these sites that were determined were compared with the definitions of the site index of the mangroves of Tabasco according to Dominguez et al. In 2011. For the species Lavonculera racemosa, they classified it in medium and low for sites 1, 2, and 7 and 8. In medium 1 in 5 and 6, and high and medium in 3 and 4. The site index for the Rhizophora mangle species were classified in a lower class in sites 3, 5, and 6, medium to low in 4 and 8, and medium in 1, and medium high in 7. For the Avicennia hermina, they were classified in medium to low in the 8 different sites. On the 7th one, we presented a higher level of site index in the species Rhizophora mangle. However, the content of carbon is low if we compare it to the other ones. And the oil fields and all the different areas serve as an access for logging and extracting wood. even the oil industry has contributed for the modification of the original soil that has transformed it into a techno soil. And this has enabled the modification of the original soil and vegetation. Gustavo, you have to finish now because you have exceeded your time. Well, as a conclusion, in UMA, Avicennia germinans presents a higher amount of carbon with 47%, more than Racemosa that has 28, and Rhizophora mangle with 23%. On area 3 and 4, we presented a higher site index for Laguliculera racemosa, with the highest productivity in these two sites. However, these amounts and this information that can be observed has been useful for the decisions that will be made in the unit for the landowners and for the preservation of the site, and even for everything related to the preservation and mitigation of greenhouse gases that might be done or achieved through these large amounts of carbon dioxide that is being generated every year. So that will be all by myself, and well, thank you for your attention. Well, with this, we conclude the first panel on ecosystemic services. Thank you for your assistance and your attendance to all the participants.
quinto Congreso Mexicano del Ecosistema de
Work
Manglar.
of this fifth Mexican Congress of the Mangrove Ecosystem. Now I am pleased to present this keynote presentation by Dr. John Boone Kaufman. The conference is entitled Ecosystem Values and Threats of Latin American Mangroves and Beyond. Dr. Boone Kaufman is a research professor of ecosystemic ecology in the Wildlife and Fishing Department of the University of Oregon State University. He is the main researcher of an international consultant company, Science International, that deals with ecology of natural resources, research and technology transfer, as well as the teaching efforts of Dr. Kaufman, are centered in the understanding of the dynamic interactions between the use of soil, climate change, and how they have an impact on the ecosystemic services. A large part of his current work focuses in quantifying the values of the coastline and the wetlands in these river areas and the tropical forests, with the purpose of coming up with mitigation strategies facing climate change. His research focuses on measuring structures of diverse ecosystems, biodiversity, carbon stocks, greenhouse gas emissions, and carbon sequestration associated to the use of soil and restoration. Most of his work focuses in a multidisciplinary manner because he has collaborated with social scientists, biologists, physicists, and Dr. Kaufman provides also technical assistance throughout the world, and he has focused his work on the dynamic of the use of soil in marshes, mangroves, tropical forests, temperate forests. His most recent research activities focus on Brazil, the United States, Gabon, Liberia, Senegal, Indonesia, Mexico, Costa Rica, Palau, Honduras, in the Arab Emirates, Dominican Republic, and other tropical countries. Dr. Kaufman also supports and contributes with his knowledge in international working groups on political and sciences when it comes to carbon mitigation, climate change. He is a co-author of a special report from the International Panel on Climate Change regarding the changes in soil coverage, and he's also the leading author of a supplement in different panels in 2016, understanding the emissions of greenhouse gases in the wetland section. He has been a scientific advisor of the Coalition for the Tropical Forest. He has published more than 250 articles, including 140 book chapters and articles, peer-by-peer review. He studied his PhD at Berkeley University, and he lives in Oregon with his wife, Diana. We are really pleased to receive you today, Dr. Kaufman, and please go ahead with your presentation.
Your microphone is mute, Dr. Kaufman.
Can you hear me now?
Now,
Hello.
yeah, perfect. Thank you.
Okay, good. Yeah, sorry about that.
Y
Ok, muy bien. Y muchas gracias por esa oportunidad a hablar con ustedes hoy. Infelizmente, porque del pandemic de COVID no puede viajar para México y por eso no tengo muchas oportunidades de hablar español. Entonces yo creo es mejor si dar esta charla hoy en inglés.
Better if I give my presentation in English and maybe a little Spanglish. And I am so sorry for that issue.
To start off with is it's very important to work in mangroves, and it's it's gratifying, it's very satisfying, fun working with people like Dr. Humberto in the Pantanos de Centla and other places of the world. But it's also very important because of the importance of these mangroves. And as you all know, what is carbono azul or blue carbon? What is the carbon?
Las regiones intermareales, en los marismas y en diferentes áreas que son muy importantes porque por su inclusión. Y hoy quiero hablar de esto, cómo incluirlos en la mitigación y adaptación al cambio climático y las diferentes actividades que se realizan, porque el carbono se almacena en el suelo y este es un componente muy importante de estas zonas. Rápidamente, como revisión, quiero decir que los sumideros de carbono incluyen los pastos marinos en la costa de Yucatán y en otras áreas de México y es muy extenso. Estos pastizales son muy extensos y es muy importante también hablar de los marismas.
The Northern American areas, such as my home down south, you can see below in South Slough, Oregon, very, very large carbon stocks, but also occurring in areas like Siancan in Mexico, and even close to the Boca del Rio Amazonas in Brazil. And these also have very, very significant carbon stocks as well as sources of biological diversity, such as habitat for the very rare whooping crane, as you see here in the middle picture. So anyway, the mangroves then, what I'm going to talk about largely today, as you all know, are a type of tropical forest in the intertidal zone. They're keystone ecosystems for many values, both marine values and terrestrial values. They exist in at least 124 countries, and they're not widely extensive, though. They only cover perhaps 138,000 to 152,000 kilometers. But because of their high carbon stocks, high emissions with climate change, and the fact that they're being lost at alarming rates, they may have as much as 10%. They may represent as much as 10% of the greenhouse gases that arise from tropical deforestation. And I'll come back to this later on in the presentation. Mangroves are not a single type of ecosystem, as we've all talked about here. There's tremendous ranges in structural diversity, such as these that are 65 to 70 meters high in Papua, Indonesia, but they may be very mature, very important mangroves, the Mangle Chaparro, that are only a meter high, such as we see here in Siancan. There are at least 70 to 90 species of mangroves in the world. Here's some Sonoradia alba from the Federated States of Micronesia, with huge trunks, very large forest, as well as very magnificent nematophoros. We have some very interesting ones. Peliciria rhizophyri from southern Mexico, mostly on the Pacific coast down into Costa Rica, bat-pollinated mangroves. And of course, even in much of Southeast Asia and the Eastern Pacific, we even have a palm-dominated mangrove, Nipa fruticosa, no trunks, but leaves that are as high as 15 meters high. And then finally, while much of our work is in the rural areas and in reservas and places such as this, it's very important to know that mangroves also exist in many urban areas of the world, such as here in the United Arab Emirates, where it's really the only forest that exists in this part of the world and are highly valued by the people for a variety of aesthetic and cultural and educational values. So when we look at then the total ecosystem carbon stocks, then when I talk about tremendous ranges in biodiversity, this is the range and ecosystem carbon stocks of 190 different mangroves from throughout the world. The green parts are the above ground biomass, the brown is the below ground biomass, and these are bars of 190 different sites that we've sampled in the same way to depths as great as 3 meters. You can see the average then of the biomass or of the ecosystem carbon stock is 856 tons per hectare, but the range is 79 to 2,208 tons of carbon per hectare. So you see there's a tremendous range throughout the world in composition, structure, and ecosystem carbon stocks. One thing, though, throughout the area, though, is these coastal ecosystems, these blue carbon ecosystems are keystone ecosystems for humanity. They provide a disproportionate number of services relative to their very small area. And even though they only make up about 4% of the planet's land area, the coastal zones, they're home to 1/3 of our population. And about 15 years ago, this was predicted to double, and so it's probably twice that now. What are some of the ecosystem services of mangroves that are so important that we need to address and that can be addressed not only, and should be addressed not only or that would be an additional through the conservation restoration, say, for climate change mitigation? First, of course, that we think of is the provisioning services, their values for fish, shellfish, seeds, medicine, wood, energy, etc. There's a variety of regulating services. This is the timing of flow, of carbon and nutrient cycling, influences on decomposition, and that's therefore climate regulation, supporting services such as water and air purification, pollination, seed dispersal, biological control, and protection from storm surges associated with hurricanes and tsunamis, cultural services, the inspiration that we get, both recreation, scientific inquiry, and finally, the preserving services, the diversity for future use, preserving options. And this is where climate change mitigation and adaptation also comes in. So climate change, so conservation, restoration in terms of climate change, adaptation, and mitigation is not only a regulating service, but also a preserving service. So what are these values worth? It's been estimated by the United Nations that these ecosystem services may be as much as a value of $33,000 to $57,000 per hectare per year to the national economies of developing countries. Some of these values, of course, that come to mind are the fish and shellfish, and these are important not only for commercial values, but also for indigenous peoples, subsistence fishermen, indigenous peoples who live on the coast who have depended on the fish and shellfish as a source of protein and nutrition for generations. in terms of commercial fish species, studies in Mexico, Australia, throughout the world have found that 32 to 75% of all commercial fish species pass part of their lives in mangroves for nursery grounds, shelter, and food. And of course, again, for subsistence fishers, for local people, this might be 100% of their fish come from the mangroves. The mangroves also have very strong linkages for nutrients in terms of purification of water, sources of carbon or energy for the coral reefs as well. And of course, as I said earlier, they're very important for cultural values, ecotourism, science, education, spiritual values, and this is, of course, a strong value, I think, for the people of Mexico and throughout Latin America. And of course, there's a unique and tremendous biological diversity that exists in wetlands. And yes, it is true. I have actually seen elephant dung and elephant trails through mangroves in Gabon. And all these other species are species that were filmed or photographed in mangroves throughout the world. Of course, their values for birds as nesting sites is well known. But it perhaps is the biological diversity and the density of the benthic invertebrates that is so important in terms of nutrient cycling and the structure and the function of these ecosystems. And of course, there's some very many charismatic species in the world, some of the highest densities, if not the highest densities of tigers in the world are in the Sundarban Reserve. That's my hand with the tiger that had walked through our mangrove while we were working in it in Bangladesh. And then finally, there's some large animals. This is one of our study sites in Kalimantan, Indonesia. That's about a 5-meter saltwater crocodile. That's our study area. In the background, the Nipa mangrove, and that is our significant barrier to scientific progress. And my students, this was taken from a boat, my students told me, no work today. Mangroves also function to protect coastal settlements from storms, tsunamis, hurricanes such as Zeta that is affecting Yucatan right now, in a changing climate. And finally, and I'll get back to the changing climate in a minute, and finally, forest carbon stocks. You know, it's well known now the value that the mangroves play in very, very high carbon stocks compared to tropical forest, temperate forest, boreal forest, tropical savannas, and of course the same thing would be said for the marismas as well. In order for us to understand carbon dynamics in climate change mitigation, a whole variety of factors need to be measured in the mangroves. First of all, the large green circles represent the carbon stocks of, say, mangroves, and looking at land use, in this case, shrimp ponds. It could be cattle pasture, it could be agriculture. But at any rate, so the first thing you'd need to do is get the carbon stocks of mangroves and land use. And then the large open circle then through a gain-loss method, or would be the carbon stocks. The delta C LUC is it would be the emissions due to the just the shift from mangrove to the land use. But in order to truly understand carbon dynamics, we need to also know what the net ecosystem productivity is of these sites. And that's going to entail measuring carbon uptake, and we get this through measurement of net primary productivity, measuring tree growth, root growth, litter fall, etc. And also with gas chromatographs measuring carbon, both autotrophic and heterotrophic respiration in these sites. Again, in areas such as intact mangroves, we see the net ecosystem productivity, which is basically the net carbon sequestration or loss. When it's greater than zero, these are effective carbon sinks. When it's less than 0, such as the shrimp pond, it would be net carbon sources. And this is the data that one needs to truly understand the role that conservation and restoration plays in climate change mitigation and adaptation. Again, if we just look at the roles then that mangroves play, this is average carbon stocks of mangroves throughout the Asian Pacific, Latin America, including Mexico, West Central Africa, the Arab Gulf, and then globally. And one can see, and then the IPCC default values. One thing that we note from the IPCC values that we're using to value these mangroves is that's woefully out of date today. The data on the left is data that's been collected since the IPCC, since much of the IPCC was developed. And you can see that actually the emissions that come from land use, land cover change even exceed this default value by the Intergovernmental Panel on Climate Change. So overall, the global mean of about 856 tons per hectare is a pretty good average, both for globally, but it's perhaps somewhat a little bit higher in Latin America, as you can see. So just to give you an example of some of the data that needs to be collected in climate change mitigation, let's use the Pantanos de Centla for an example. This was an excellent place to work because it has areas of intact mangrove next to cattle pastures. And you can see here's Dr. Humberto and Jesus del Carmen sampling the carbon stocks in an intact mangrove while their students are hard at work in the open pasture that used to be mangrove. And you can see that the mangrove they're working in is in the background, and the foreground we're working in the pasture. And this is the data, that results that we get from these sorts of studies. Here's 3 pairs of pasture mangrove comparisons. The Mangle, M. cometa, M. gallego, M. vidal are mangroves, and Pastizal cometa, Pastizal gallego, Pastizal vidal are the pastures. And you can see the carbon stocks. The black is the carbon stock in the soils, and the other colors are basically the above ground and below ground tree biomass. As is the case for most mangroves, about 75 to 95% of the carbon is below ground. And we see tremendous losses with land use, land cover change. And one can see the least amount, the average for the mangroves in this scenario was about 990 for the mangrove and about 275 for the pasture. If we take those numbers then and just look at the potential emissions that would come from that, the cometa, the very old pastures greater than 20 years old, had huge carbon fluxes. The emissions on the basis of carbon dioxide were over 4,000 tons of carbon dioxide emitted per hectare from that site. The Gallego site, slightly less than 1,000 tons of emission, is due to the fact that that's a pretty young mangrove, or a pretty young. So the pastures tend to lose carbon throughout their lifetime. The Vidal was a little bit older as well. And our overall average emissions then that come from the conversion of mangrove to cattle pasture in the Pantanos de Centla in Mexico was about 2,600 tons of CO2 equivalents per hectare. So there are tremendous sources of greenhouse gases when the decision is made to cut down a mangrove and convert that into a cattle pasture. So let's look at some of the other factors, the net ecosystem productivity, and how do we start to value this? And so in many areas of the world, we have looked at net ecosystem productivity by measuring net primary productivity of the forest, as well as the shrimp ponds. Here's an example from Indonesia. Here's one of my in the lower right-hand corner, you can see my graduate students measuring the CO2 flux from a shrimp pond. And we can start to value then this carbon looking at if this was an eligible project, what would be the value of a mangrove? And let's use numbers from the gold standard for carbon pricing, and it's currently around $14.70, 14.7 US dollars. If we look at the difference in net ecosystem productivity between the mangrove and the ponds, that would be the carbon that we would have sequestered through time. That difference we have found from studies in Indonesia is about 37.4 megagrams or tons of CO2 equivalents per hectare per year. So if we take that, multiply that times the value of a ton of CO2, that's about $550 per hectare per year. Now, if we take the data like we got from the Pantanos de Central and look at avoided emissions, if you conserve the mangrove and didn't cut it down over a 20-year time frame, which is a standard time frame that we use for valuing projects, that comes out then to an average of about 27 tons of carbon per hectare per year. If we assume that those emissions are over a 50-year period, then that's only about $398.50 per hectare per year. So the total value then, adding up these two areas, the difference in net ecosystem productivity and the avoided emissions would be a value of these mangroves in, say, a climate change mitigation strategy of about $948 per hectare per year. These are certainly amongst the highest values of any ecosystem in the tropics that we've measured to date, far greater than upland forest, for example. Okay, moving on then to why is this important for us to protect mangroves, to sequester carbon? And it's important because of these high populations of people, the ecosystems that support them are increasingly threatened by climate change. This is just a statement from the U.S. Global Climate Change Research Program from a little bit late 2 years ago. And without significant reductions in greenhouse gas emissions, regional adaptation measurements such as restoration, conservation of mangroves, many coastal regions will be transferred by the later part of this century. Our children and grandchildren will see the impacts affecting other regions and sectors. And even in a future with lower greenhouse gas emissions, many communities are expected to suffer financial impacts as high tides, flooding leads to higher costs, lower property values, and greater threats to human health and safety. If we just look at where the sources of sinks, if we have to reduce emissions, we can look at the Global Carbon Project's latest estimate. It's about 86% of the greenhouse gas emissions are coming from fossil fuel burning. About 14% are coming from deforestation. And remember, somewhere between 1 and 10% of those greenhouse gases that are coming from deforestation are coming from the mangroves. The sinks are also very important to know. About 29% of the greenhouse gases that are emitted by the fossil fuels and deforestation are sequestered by forest, and about 23% are sequestered by oceans. Whether the mangroves are considered marine or forest, it shows their importance for inclusion in climate change mitigation as how important it is to slow rates of climate change by having forest sinks, oceanic sinks functioning to sequester this carbon. And of course, there's about a 4% uncertainty in these data. How will this affect coastal ecosystems? We see changes in temperature, both sea temperatures and air temperatures, the warmest September on record this year.
Tuvimos el septiembre más cálido que se ha registrado, también aumentan eventos como el Niño, la sequía,
increased severity of tropical cyclones. The number of hurricanes that we've had this year has been unprecedented. We're seeing increases in sea level, chloral bleaching events and ocean acidification events that we've never seen before. If we just look at, of course, with a 1 meter inundation, we see huge impacts to people of the world. Some of the largest mangroves in the world that you'd see here in Southeast Asia would be underwater. The Mekong Delta, home to over 14 million people, would be underwater, and thus creating a tremendous social as well as biological and ecological catastrophes.
Muy trágico. Sería una catástrofe. Es importante saber que los manglares están adaptados y evolucionan con el estrés que involucra vivir en esta interfase entre los tifones, pero se ven muy amenazados por el cambio del uso de la tierra y por lo tanto los resultados del cambio climático también. Y también es muy importante recordar el impacto del uso del suelo, de la cobertura, están teniendo un impacto en la biodiversidad a un gran nivel. El cambio climático, si hoy en día analizamos en general el 85% de los humedales en el mundo,
and that rate's continuing, and sad to say some of the most rapid rates of wetland loss are continuing in the tropical wetlands of the world. Loss of wetlands is 3 times faster than forest loss globally again. About 1%, maybe a little bit less, of mangroves are being lost annually throughout the world. And this is largely due to las presas, dams, salt, las salinas, así como camaroneras, shrimp ponds, agricultura, pastos, palma de aceite, arrozales. Road development is a huge issue, such as you see here in Yucatan, and coastal development, the building of hotels and others. As you can see, this huge accumulation of carbon where they're building a hotel, again, in Yucatan. And the same thing, again, the threats to ecosystems in Latin America, the same ones as we see throughout the world, contaminación and others. Okay, if we just look then at when we convert the areas, as we mentioned earlier from the data from the Pantanos de Centla, here's just an example of the carbon emissions from converting mangroves to shrimp ponds throughout the world. We have studies. The first ones, though, the little green boxes, the Mexican dry forest and the Amazon rainforest. The Mexican dry forest is Bosque caducifolia from data that we collected at the Estación Biología de Chamela in Jalisco. You can see its emissions is about, when you convert a Bosque caducifolia to pastizal, you get emissions of about 250 tons of CO2 equivalents per hectare. Amazon rainforest, greatest rates of deforestation in the world. That deforestation conversion to pastizal or to soy is about 750 tons per hectare. And we can, again, compare that to the conversion of Mexican mangrove to pasture in the Pantanos de Centla. Its mean was about 2,800 tons per hectare. And then we see the range of the rest of these, Honduras, Brazil, Costa Rica, Indonesia, Dominican Republic. Those are all the conversion of mangrove to shrimp ponds. The active ones we see, such as in Honduras and Brazil that we were measuring, 1,200 to 1,400, were young mangroves. The oldest mangroves, such as República Dominicana in Indonesia, much higher rates of climate change emissions, because for many years following deforestation and certainly following abandonment of the shrimp pond, you see emissions that continue as they continue to be sinks of carbon dioxide rather than sources. And I might add that we find carbon losses at depths, significant carbon losses at depths of 2 to 3 meters, underscoring the importance of sampling mangroves at depths greater than 1 meter, preferably to as much as 3 meters, because because these deep soils are significant sources of greenhouse gases with land use, land cover change. But important number to know, though, is the mean emissions from land use, land cover change for the conversion of mangrove to other land uses is about 2,000 tons per hectare. That's 3 to 4 times greater than on rainforest or Bosque caducifolia to other agriculture, say. So let's just then talk about, we scientists quite often report to the United Nations how much carbon is lost in a petagram. And how much is a petagram? And I try to tell my students that and my friends that. It's about 1 billion metric tons. But it can be definite. It's difficult for the public to comprehend what a petagram is. And this might engender apathy and a lack of concern to how important these ecosystems are and how much they're contributing to climate change. So in order to present how deforestation, land cover change contributes to climate change in a comprehensible manner, let's change the scale of greenhouse gases to global scales to a personal scale and ask a question, well, what is the jumbo carbon footprint of a little shrimp? In other words, what is the carbon footprint of a beefsteak and a shrimp cocktail dinner? And this is the results of a paper that Beto and I, many other authors, several years ago did for Frontiers of Ecology and Environment, and it made the cover of the journal. Everybody knows that the carbon footprint is the total amount of carbon dioxide and other greenhouse gases emitted over the life cycle of a product. But as an ecologist, as you look very closely at the data, rarely are the costs of deforestation and land cover change included. And this results in vast underestimates of the carbon footprint of things such as beef that would come from mangroves and clearly the shrimp that would come from shrimp ponds, as you see here. So we made the term, what is the land use carbon footprint? And we define that as the carbon emissions that arise from the conversion of an ecosystem to another land cover type in order to provide some commodity. We've been able to do this for logging and upland forest, Bosque caducifolia, Bosque evergreen forest, as well as shrimp ponds and pastures. Okay, so we ask then, let's scale these greenhouse gas emissions down to a dinner plate and ask the question, what would be the quantity of greenhouse gas emissions from a dinner consisting of a steak from a mangrove, the Pantanos de Centla, and a shrimp cocktail from Southeast Asia, where we've done a tremendous amount of work in the shrimp ponds. But probably numbers would be very similar to what we would see on the Pacific coast of Latin America as well. If we look at the mean emission rate, again, from the Pantanos de Centla, it was about 2,600 tons of carbon dioxide per hectare. We need to add to that then in the life cycle analysis, the methane emissions from assuming a stocking rate, a very generous stocking rate of 1.25 head of cattle per year. That would give us an additional 48.4 kilograms of methane per hectare per year. The total emissions over a 30-year period with a global warming potential of 34 would be about 49 tons of carbon per hectare. The nitrous oxide emissions from manure alone would be 12.5 hectares. Carbon not sequestered over 30 years, that's the loss of net ecosystem productivity, is 187. Total emissions then would be 2835 tons of carbon dioxide equivalent. Okay, that's the losses. Now, what is our gain? How much meat do we get? Very, very generous to the cattle productivity. Assuming high productivity of cattle, we'd get about 123 kilograms of cattle gain, of which 50% would be meat, giving us about 1.8 tons of meat per hectare over the life of that pasture. Therefore, just taking the carbon, the meat, the productivity divided by the emissions gives us the land use footprint for beef at about 1,534 kilograms of CO2 for every kilogram of beef. So therefore, a 1 pound steak would produce about 1,534 pounds of CO2. And again, we calculate the same for the shrimp ponds as well. If we look at the shrimp ponds, the footprint of carbon is basically determined by looking at the total loss of ecosystem carbon due to land cover change, the emissions of N2O during the active shrimp pond conversion. Because it's saline, we don't get much methane. Carbon sequestration that would have been sequestered in the absence of deforestation is also in the equation. And then we divide that by the productivity of the shrimp, the productive times the life of the shrimp pond times the proportion of the shrimp that's meat. And again, the data that I'll present today are from extensive low input shrimp ponds that don't use electricity, use tidal fluxes alone, or perhaps just small pumps. The productivity here is much, much lower than the intensive shrimp ponds, only about 500 kilograms of shrimp per year. These are notoriously low, short-lived because of disease, because of iron sulfite soils, because of failures of dikes, about 3 to 9 years, but we'll assume the longest life of 9 years in this analysis, giving us the shrimp productivity again is gives us then over the life of that thing is 150 to 4,000, midpoint of 2,400 kilograms. Again, in intensive operations with lots of inputs of fossil fuels, fertilizers, supplements, antibiotics, it can be much, much higher. And we assume that the edible meat is 45%. This would lead a total productivity of about 1,000 kilograms of shrimp per hectare. So the mean loss of carbon from the conversion of a mangrove was 1,783 tons of CO2. Nitrous emissions added a little bit more, and that gives us a land use carbon footprint of 1,652 kilograms of CO2 per kilogram of shrimp meat produced. And so we ask ourselves, this little bag of shrimp, is it worth almost a ton of CO2? A 1 pound bag of shrimp that we see in our markets, that's very, very common. The most widely consumed seafood in Europe and the United States today is this farm-raised shrimp, but it has carbon footprints that may be as much as 1,474 pounds of CO2. So if we just look at the land use carbon footprint of a shrimp cocktail, it's also important to remember that this does not include the effects of habitat destruction, the biological diversity, the effects of overfishing of other organisms to certain speed, the cost associated with waste pollution, which may kill adjacent mangroves, spread of diseases, white spot being the most relevant one, overuse of chemical treatments, as well as the social issues associated with the shrimp industry. Doesn't include cost of feeding, establishment, management, fertilizers, medicine, shipping, process, etc. This is only the carbon loss by land use, land cover change, nor did it cover the loss in ecosystem services or impacts on other ecosystems from the loss of mangroves, including their loss as values of carbon and carbon storage. So let's just make an assumption then. Assume that you and your friend go out to dinner to a restaurant, and both of you are very hungry, and you order the surf and turf dinner. That's what we call the United States, when you get a large meal consisting of a shrimp cocktail and a 16-ounce beef steak. Here you can see on the menu. So let's assume that the shrimp and the beef come from tropical sites. The shrimp comes from Southeast Asia. The beef comes from the Pantanos de Centla, where mangroves have been converted to the production of these use. The ecosystem carbon footprint of each of these meals, your shrimp cocktail and steak, would burden the atmosphere with about 858 kilograms of CO2, about 697 kilograms for the steak, and about 161 kilograms of CO2 for the shrimp cocktail. The mass of the carbon footprint for these two meals combined, you and your friend's meal, would be equivalent or greater than the mass of the car they arrived in the restaurant. In other words, a Toyota Prius weighs about 1,382 kilograms, and the CO2 equivalence of your two meals was 1,716 kilograms. And so the ecosystem carbon footprint from this dinner would be equivalent to the emissions from burning about 730 liters, which is 193 gallons of gas in an automobile. So we could drive from Los Angeles to New York City, and the carbon footprint would be lower than this meal. Or you could drive from, say, Mexico City to Los Angeles, and it would be a lower carbon footprint. So, in conclusion then, these coastal ecosystems, particularly mangroves, are considered high priority in adaptation and mitigation for climate change for a variety of reasons. And in fact, we are including these blue carbon ecosystems in the next report for the IPCC. And this is for 5 reasons. They have exceptionally high carbon stocks, amongst the most highest of all the ecosystems in the world. And in fact, even the marismas have carbon stocks that are equivalent here in Oregon, where I live, equivalent to the large old growth forest of the uplands. The rates of land cover change and deforestation are amongst the highest in all of the tropics still for these areas. And sad to say, the emissions from the land cover change is also much, much higher. Remember, it's 3 to 4 times higher than the conversion from uplands. And we not only lose the carbon and shift these from significant sinks of carbon to significant sources of carbon, but we lose these incredible ecosystem services that are important for the sustainability of local communities, their life and infrastructure. And finally, it's very important that with restoration, the rates of carbon gain is quite high. And fortunately, these areas are restorable and can be restored, and the values associated with restoration, the rapidity with which ecosystem services return is very, very rapid and very important. So just some of the conservation of mangroves that may be important for the business community of the world, and some of the recommendations is promote the conservation and restoration of mangroves and get them part of carbon markets and programs such as REDD Plus and corporate social responsibility programs. We need to create actions, include the mangroves in nationally appropriate mitigation actions of the countries, the NAMAs, for all countries, including Mexico and many countries throughout Latin America. We need to promote economic incentives for their conservation and restoration that are beyond carbon, such as payment for ecosystem services, for all these other values that they provide for people. Finally, we need a better conscientious and awareness of the importance of mangroves, education of the importance of mangroves, and we need to develop the capacity for including these in both. Impoverishment and biological soy y lo siento mucho por la charla. Está en,
Disculpa por haber dado la presentación en inglés.
Gracias.
Muchas gracias. Si alguien tiene una pregunta, puedo responderla en este momento. Voy a dejar de compartir la presentación. Gracias, doctor Kaufman. Tenemos un par de preguntas. Una de Claudia Hernández. La pregunta es sobre
You that know the mangroves ecosystem in Mexico, you have been studying them. Which could be the research questions, the priorities research question for the blue carbon subject in Mexico? What do you think about the
That's a very, very important. Mexico is blessed with some of the most extensive mangroves in the world, and so it can play a very important role in its climate change mitigation and adaptation. Now, what I would suggest then is that we need better information on the roles that conservation plays. What is the net, what are the emissions with land use, land cover change of the shrimp ponds, which we have very little data in Mexico, agriculture, which we have very little data, and what are changes in the net ecosystem productivity? What are the greenhouse gas emissions that come from mangrove? How do we balance? Again, let's get the net ecosystem productivity so we can get a good idea of the true cost of land use, land cover change, and be able to apply that to economic models then. So in short then, good data on carbon stocks, good data on emissions. From both intact and mangroves. And then finally, restoration, approaches to restoration, the value. Use of restorations, rates of carbon sequestration associated with restoration are other areas that not only are lacking for Mexico, but are lacking for the world. So.
Okay, yes. We have another question, and it's from Julio Salas. is whether should new mangrove projects in Latin America be directed? I mean, in this whole war of interesting research, what is the need of the hour?
Yeah. Probably the most important thing to do would be first stop cutting down any additional mangroves, because we lose so much. You know, we lose over 2,000 tons of carbon per hectare for every mangrove we lose, plus the immeasurable amounts of ecosystem services. So the most important thing to do would be halting the deforestation and the destruction of any additional or any remaining mangroves. Secondarily, strong national plans for their restoration and restoration in areas that formerly were mangroves. Sad to say, so much of our restoration is failing. Today because of poor planning on where to site the restoration activities. So often we're siting them in areas that are mudflats and not formerly mangrove. And secondarily, planting mangroves is the last thing you do in a restoration. The first thing we need to do is establish tidal flows, tidal fluxes, get the energy and hydrologic considerations established first, and then only if necessary will you need to plant. Mangroves are pretty invasive species. If you create the conditions, the physical and hydrologic conditions for their establish, quite often they'll establish on their own. So planting is the last step, not the first step in restoration. I hope I answered that question for you.
Okay. Next question is from Patricia Ocaña. What do you think about sargassum in the Caribbean, Mexican coast is influencing the blue carbon sequestration?
I assume you're referring to the large kelp, the sargasso kelp?
Yeah, exactly.
You know, one of the things is that is a pretty rapid carbon cycle. There's a lot of growth there, but it's rapidly turning over. It's not, there's very little long-term storage. There's little storage, for example, in the soils. It's turned over in the plant. So it's probably, I mean, it's clearly the ecosystem values of the sargasso are immeasurable and very, very important. But in terms of a carbon stock, it's probably less than those that maintain large stocks of carbon for thousands of years, say, in soils or even in large woody structures, which the sargasso doesn't have.
Okay, very good.
But we definitely probably need more. You know, that has been a very, very frequent question in the International Blue Carbon Working Group, and I'm sort of parroting many of the results that has come from that group that Jorge Herrera and Lopez Portillo have been involved with as well, and they I'm sure could address this issue as well. But the jury is still out as to its overall value, but giving again the rapid turnover versus long-term storage, it's probably not as significant as say mangroves.
Because the cycle is so fast, right?
Yes.
And there is no other purpose for the kelp immediately, right?
No other purpose in.
I mean, production or
Right.
second use or anything like that.
Well, it's almost all in net primary productivity, but it's a rapid turnover. Like it's sequestered the carbon, then it decomposes very rapidly. Now there is some thoughts of that so much of this carbon may go to deep carbon pools. So if significant quantities of the kelp and other algae go to deep carbon pools that would be sequestered for long periods of time, then it would have value. But we still don't have very good understanding of it going to long-term carbon storage. In other words,
Okay.
is it resulting in a net decrease in atmospheric CO2?
Okay, very good. I think that Dr. Humberto Trejo is gonna acknowledge you for your talk.
He's too kind.
Yeah, but I think that he is not online anymore. So, Dr. Kaufman, we appreciate your time. We appreciate your talk. Thank you very much for being virtually here with us. And we wait for you for the next project in the Pantanos de Centro.
I just only wish I would like. Well, we're hoping to start a project looking at carbon stocks and restoration from the entire Pacific coast, from Mexico to Ecuador. So hopefully, if anybody's interested in collaborating, I would like to talk to many people who would perhaps could provide some insight on working on the Pacific coast. So
Great. Yeah, we have right now here in the meeting a lot of experts in the Sea of Cortez, in Baja, that will appreciate.
Welcome to today's vegetable information table. So we're going to be continuing with a series of conversations from different participants, starting by the different work and affectations in the mangroves of the Nush Lagoon, presented by Fernando Sevillano Aureliana, jointly with Benjamin Castillo and Erlina Erdanzo. So we'll have a couple of minutes for the presentation, and we'll afterwards give some time to ask a couple of questions. So Fernando, the floor is yours. Thank you very much. So manglares are vegetable formations where we have the dominion of bushes, also known as the mangrove. These are especially known for being very resilient, having a high degree of salinity. So this ecosystem is considered one of the most valuable and productive ones on planet Earth. It is located in different regions around the world, both in tropical weather as well as subtropical weather.
Como es la producción de alimentos, la producción de madera, protección contra tormentas o tsunamis, el mantenimiento de la calidad del agua, la retención de nutrientes, el almacenamiento y captura de carbono, entre otros servicios ecosistémicos. A pesar de la gran importancia que tienen estos ecosistemas costeros, actualmente se encuentran bajo amenaza debido a las diferentes actividades antropogénicas y naturales, como lo es el cambio de uso de suelo, por diversas actividades como la agricultura, la ganadería, la acuicultura, la contaminación por residuos sólidos urbanos, el vertimiento tanto de aguas residuales como agropecuarias y como fenómenos naturales, huracanes, tormentas, ciclones. Diversos estudios han demostrado la estrecha relación socioeconómica de las comunidades rurales que se encuentran acentuadas a un cuerpo lagunal y su influencia de manera directa e indirecta con los recursos naturales que otorga este ecosistema de manglar. Un estudio realizado por Newton en 2020 menciona que las alteraciones que se dan en los manglares es debido al desarrollo económico y por las actividades humanas que ahí se ejercen. Por otro lado, también Hayashi en el 2019 en la costa de Brasil reveló que la red de carreteras, los asentamientos y el crecimiento urbano son impulsores del cambio y uso de suelo en los manglares. Y finalmente López y colaboradores en 2013 en la laguna de Tres Palos reportó que la contaminación del cuerpo de agua de la laguna es por el vertimiento de aguas residuales y por los tiraderos a cielo abierto de residuos sólidos urbanos. Existen pocos estudios referentes a las afectaciones antropogénicas que presenta el ecosistema de manglar adjunto a la laguna de Nusco. Por ejemplo, Benson y colaboradores en el 2016, mediante el uso de los sistemas de información geográfica, encontró que la mayor pérdida de cobertura forestal de manglar es a causa del cambio y uso de suelo a áreas para la agricultura. El objetivo del presente estudio fue identificar las afectaciones antropogénicas de los manglares de la laguna de Nusco con la finalidad de conocer el vínculo entre los componentes ambientales del recurso manglar y los habitantes de la localidad 20 de noviembre.
In the community of 20 de noviembre. The methodology of the area of study is located on the 20 de Noviembre locality, which is part of the Telpeternana municipality in the Costa Grande region, which presents a temperature that varies between the 14 and 18 degrees Celsius, with a rain level of between 800 to 2,000 millimeters. This study took place in the time made up between 2017 to 2018. They did a random sample of 158 people between a total of 705 members of the 20 de Noviembre population, based on the information provided by Cedesol, and in accordance to the Appendix 2002, the size of the sample was determined, considering that this was going to be selected sample of population. They applied a survey of a qualitative nature taking place in different homes, landscapes where they perform fishing, for example, and areas that the locality use, looking mainly at the Moscow lagoon pollution, as well as different uses and ways to profit from the ocean. On the other side, with some key characters from the population, different field parkour took place in 4 strategic points of the lagoon, being selected for being more representative and having more forestal coverage, with the goal of being able to corroborate the information provided by the inhabitants of this location. The study was performed with a statistical analysis, a descriptive analysis between the use of SPS software version 15.0. In accordance to all of the surveys implemented of what the current expectations were regarding the atrophic situations on the mangrove ecosystem, gathering therefore the following indicators. Lagoons pollution. In accordance to the inhabitants that were surveyed, 42% of them agree that there's residual waters in the lagoon's body. However, 64% of the inhabitants that were surveyed said that they agree with the existence of the pollution on the lagoon because of the solid residue disposition in nearby areas close to the mangroves ecosystem, whose final destination for this solid waste is 67% burned, 11% is stored in homes, and 9% is placed in containers, and 4% is dropped on the lagoon, causing therefore a severe impact on the mangroves ecosystem. From the field parkour that was done, they found evidence of open sky droppings close to the mangroves ecosystem. On the other side, there was also a discharge of residual waters at homes that go directly to the lagoon. And they also observed aquical ponds, which is a big issue because of the reproductive condition of the marine fauna that is reproduced. They pour the water to the lagoon, which is something that can cause a lot of pollution, and it might be harmful for human health. That is the current situation of the mangrove of all the surveyed citizens of the area, which 52% of them agree on the existence of areas that are deforested as a result from activities for agriculture, cattle, livestock, and apiculture. They also found that 46% of the surveyed population think there is a rational profiting of the mangrove ecosystem, while 9% affirm that this profiting does not exist. Therefore, being this type of mangrove bottoms here, or the bottom mangrove, the one that is used the most, the one that represents biggest resistance to plagues and pollution. In the second place, with 19% of profiting, we can find the tea mangrove. And afterwards, 16% of profiting would be for the Candelilla mangrove, which is used by the population as a medicine complement. And with a lower degree of profiting, with only a 6%, we can find the white mangrove, given the fact that it's attacked by a lot of plagues and pollution. And at 25% of the surveyed population affirmed that they do not use any type of mangrove exemplaries as a additional resource, being mainly used for gathering wood, cotton, construction, or for the household of the population, and with a lower degree of use for carbon. Therefore, mentioning that in the past 15 years, the mangrove have been attacked and have decreased number for many anthropogenic action as well as by natural actions. As a conclusion, finally, with the decision of this study, we managed to understand and know that the mangroves area is in great deterioration, ecological deterioration, given all of the anthropogenic diverse actions and activities that take place around the mangroves ecosystem. Thank you very much for your attention. Thank you very much. Now let's open the floor for any questions. If any of the assistants have a question and they would like to make us know about it, it would be the best time to do so. Fernando. So what do people think the inhabitants of the region? How do they see the mangrove, the inhabitants of this population? Well, by the end of this interaction that we had with the inhabitants, they say that the mangrove generates great benefits, especially for the attention of the resources. But likewise, they also, at the same time, they need to profit from this mangrove in order to be able to subsist. So they've reiterated that they need projects in order to have sustainable use of the mangroves ecosystem. And the research is interesting of generating these research projects exist for this type of development projects. So far to this moment, this is part of my degree of my dissertation. However, as a proposal, something that we've established as part of the established proposals towards the was the creation of these different greenhouses with a species of the Cactus erectus, for example, to profit from this type of species. So amongst all of the conversations that we've provided, they accepted to participate. However, they also do need the support from the government in order to be able to really land all of these projects that might prove to have benefits both social and economically and socially, especially for this locality that is found next to this lagoon body. Well, I think there's a lot of opportunity there of continue to develop work on this area. So congratulations, the best of lucks. And yeah. We would like to remind you that the next presentation, the presenter wasn't able to join in. Therefore, we're going to take a few minutes. And we'll be back in 10 minutes at 11:45 in order to continue with Alfonso Garcia Huerta's presentation of the criteria and guidelines for the establishing of the state system of protected natural areas. Therefore, we'll come back at 11:45. 11:45, we'll meet back here. Thank you.
Bueno, continuando con el programa del día, le toca a Alfonso.
It's now turn to Mr. Alfonso Garcia Huerta to introduce his work regarding the criteria and guidelines for establishing the state system for protected natural area. Alfonso, we're going to leave your video running. And at the end, we will open the floor for questions. Thank you. The mangrove ecosystem. I would like to thank the opportunity of talking about the work that we've been developing in the state ministry in the Veracruz University. I would like to start by talking about what a protected natural area is, according to the government level that manages says whether they state, municipal, national. So this work makes reference to the natural areas that are competence of the state, of the Veracruz state, regulated by all sorts of different guidelines, particularly by the environmental protection law. They are born under very different purposes, with a scope of preserving multiple associated values to environmental services, such as ecosystem conditions, just to mention a few. In Veracruz, there are 26 natural areas under the state's competencies to protect a surface over 6,000 hectares. They're classified in 5 different categories. However, it's not enough just to decree a natural protected area. If without the proper management, their preservation cannot be guaranteed, such as the presence of menaces, assessment, monitoring. This is going to be reflecting whether they're vulnerable or not. In order to respond to these environmental management challenges, we're proposing a protected natural area system for the state of Veracruz. The methodology implemented is as follows. We implemented the strategy of case studies to analyze the study of 2 protected natural areas. We assessed the effectiveness of this assessment through the fracking tool assessment because it's one of the ones for the quickest implementation, with the perspective of having an implementation and management done with interviews and simultaneous studies for the work study. We perform a documentary as part of a general landscape of the current situation for these spaces within our state and to the legal framework. Lastly, because of the learned experiences, we were able to build a proposal. The scope is integrating criteria and guidelines for a protected natural area system for the Veracruz state. The tracking tour methodology, MER because of its name in English, is made up by 3 main parts. The first sheet regarding general information of the space to be assessed. Information sheet 2, which would be identifying any threats that may vary from high, medium, low, or they wouldn't apply depending on the case. A questionnaire survey, 28 questions in this case, which is made up by 2 different, the governance and socioeconomical, with indicators regarding the different effective components for the implementation, context, planning, input, results, and process. The case study I'm going to be presenting is for Arroyo Moreno. This is an ecological reserve made in 1989, subject to ecological preservation, and in 2008 it was named as an ecological reserve, located between the Boca del Rio and Medellín del Bravo municipalities. It is an ecosystem that has mangrove presence or pandlar, which is a medium jungle with vegetation. It has 49.6 hectares. The presence of land is both from ejido and private. It was granted a restoration and maintenance of natural resources, part of the SEDEMA, or the Ministry of the Environment in Veracruz, and the direction of the Boca del Rio Municipality Governance, as well as a committee from Giratales, with the goal of reducing the threat in the response. Amongst the different programs and threats identified by the MET evaluation and assessment, as the highest ones would be the discharge of residual water, also high temperature discharge water, settlement use, and impact caused by solid waste and trash. The protected natural area might be accessed through land and through water. There's a street that actually crosses all of Arroyo Moreno, which is known as Terraplén. And in this park, or let's say, you can observe different open sky wastelands, which are no longer operational, as well as that the area receives discharge from rainwater mixed with drainage water that ends in this ecological reserve. Another impact here is that there's basically no existence of any mortician hour between the protected natural area and the urban nearby area, nor any connotation for the use of land. Here we've got some of the results from the assessment questionnaire and survey. The governance environment was ranked from 1 to 3, where 1 was the number of people who, N was the number of people that contributed in this assessment. And here we see the number of people who allocated points. For example, here we have a pointing of 2, and 4 of those who were interviewed gave that value. The scores were gotten by getting an average, and this also quantification was done by getting as a reference the maximum scored, which are the ones that we have in brackets. In governance, the context indicator presented the satisfactory and regular or middle assessment in this room, or how the protection here works. In graph, we have the different indicators. In green, those that receive the high score, positive; yellow, the ones with a middle score; and in red, those that received a low score. In the discussion, the indicators that receive a high score must be complemented. If there are certain guidelines and normativity for management of this natural area, these are not complied with. For example, there is no updated management program. The personnel does have capacities and abilities for management. However, there are not enough regarding their management. 6 indicators got a middle score. There are some goals for this reservoir. However, they are not managed in accordance to them, only partially so. The ANDP is not properly limited. Among those that received a low score, we see that there is no educational program nor any awareness program. There's no monitoring or assessment, and the number of staff are not the right one. There's also neither equipment nor a certain budget for this space. Therefore, the results for the socioeconomical area can show with the indicators for process and result a not satisfactory process. All of the indicators were low. The participation of local communities is not enough. There are potential economic benefits that must be developed. However, they need plans in order to be able to reach this. There's little communication between managers and touristic and commercial neighbors. And Roini Moreno, it is a sample of the condition where many of our different protected areas are found, with a system that is only the compilation of data. The natural area do not comply with the conservation or preservation fundamental scope. There's no conservation scope on focus, and the financing method is not the best one in order to have the proper operation. This is why the proposed system must take into consideration 5 main criteria: the representativeness at an ecosystem level for species and cultural landscapes, which must be complementary to the federal competencies areas, which are private, as well as the public ones. For example, they might not be protecting an ecosystem at a state area, but yes, at a federal area, or maybe at a more private local area. So this complementary management system must go hand in hand with all of these other possibilities in order to have a holistic scope of the protected area within the whole of Veracruz state. The adequation, implementation of corrective perspective, and diffusion of knowledge, connectiveness between all of these natural areas, coherence, and a communication between the whole towards the scope of preservation from the state that must be in accordance to the protected natural area system, consistency, actions in order to comply with the scopes, the management, and the profitability, which is the cost benefit of the system. However, at the same time, they must follow the following functions: to increase the comprehension and analysis of the difficulties and threats of the protected area, using the ecosystem focus and see beyond the limits of a natural protected area in order to include some modifying hour in order to have better protection, scientific knowledge in order to sustain the decisions backed up by traditional knowledge and local education, which is very important. Definition of the conservation areas for each of the protected areas, and the contextualization of the threats and problematics of all 26 different state competencies, because the system must be built from this vision, from this perspective, promoting and fostering the compliance of the scopes and having different preservation goals at a state level, as well as an effective implementation, aside from implementing and really ascertaining what area is going to be the natural protected area. These must all work as a diffuser of knowledge and information, filling the gaps of knowledge, and allow different monitoring and assessment conditions that are focused to proper management and attention, having different citizens participation programs, working on the governance, whether by building a critical and well-informed citizenship, or trying and locating different associations with municipalities, organizations from civil society, the academic sector, in order to be able to understand and get the knowledge from our spaces, not in a forced unification process, but in a process for having joint vision. And reminding that protected area must be seen as some strategic points for developing actions for the development, the sustainable development. This is it for my presentation. I will stay open for any question or comments, and thank you for your attention. Well, thank you very much. Any questions from any of the audience members? We have a couple of minutes for them. Is it still feasible to maintain all of the natural areas of the state of Veracruz despite the anthropogenic pressure? Well, is it feasible? Of course it is. However, different actions must take place, just like I mentioned on the video. They must be taking place immediately because we are suffering short-term impacts. The study that we presented of Arroyo Moreno is already presenting impacts at a short term because they have identified some threats which have been maintained through several different areas and nothing has been done about it. Therefore, the values through which we have the protection of this natural area, when it's being protected, is being degraded. Therefore, we are in need of specific actions, very specific actions in order to reverse this problematic, which is another thing, because the spaces in Veracruz They're becoming islands, which are basically being separate from our environment. And we can see the example here of Jalape. We have several different state protected natural areas. However, they're kind of becoming some sort of kind of like parks because they're surrounded by urban developments. So it's important to have an instrument in order to be able to coordinate different actions and to start to reverse these sort of effects that are impacting our environment. Thank you very much, sir. And any questions, you can ask them to our presenter. We will continue now. Thank you very much, Alfonso and Carlos.
Adelante, doctor Carlos.
Bueno, continuando con el programa, vamos a darle
Okay, so continuing with today's program, we were now going to be talking about mangroves. Well, we're actually going to introduce our new speaker, which is going to be the work for the mangrove in Jalisco, a review presented by Ms. Maria Rubio Castañedo. So, if it's okay, let's just, Maria, the floor is yours. This work has the intention of determining what the current state of the study of mangroves in Jalisco is, with the scope of obtaining different research lines. We consider this type of work, aside from being needed, they're urgent, because the different tourist and urban developments in Jalisco have taken a lot of improvement in past and recent years, with a strong impact on the ecosystem. The mangroves are ecosystems rich in biodiversity. They provide a lot of ecosystem and natural resources. They're aside for feeding and resources. They're used as fuel. They're the habitat for migrative birds. They're a recreational area. They act as flood control system as well as a barrier against hurricanes. They control erosion and they protect the coast. They improve the water quality by working as a biological filter, and they contribute to the maintenance of natural processes, such as those put into question by the framework level. They're used as a construction material for houses, and they also work as a greenhouse. Mangroves are very important as an ecosystem to capture blue carbon. Unlike what happens in forests, the storage of carbon on mangroves happens mostly on the soil, and some of it also on the superficial vegetation. This ecosystem also helps in mitigating climate change, because they comply with less than 0.05% of the marine area of the world. However, they capture carbon in a 2 to 4 times greater rate of carbon capturing than forest, and they also have an equivalent of all of the emissions created by transportation at a world scale. Mexico is one of the countries that has the biggest surface of mangrove area. It represents 5% of the world average, which places our country in the 4th level out of 125 leveled countries and territories that have this type of ecosystem. Jalisco is one of the states that has the lowest existence level in Mexico, having at 2,100 hectares distributed in all of the state. The georocous distribution of the state makes this distribution of mangrove to happen in small patches. We have some rands by area in Jalisco and 2 natural protective areas with mangroves. In the work that was taking place between Linares and collaborators in 2007 in the Laguna de Barra, they proposed a unification of efforts where we can observe that the closest species to the lagoon would be the Rhizophora mani, followed by the different areas, and lastly, so before really entering the driest areas where we can find the matorral salpical and different plantations of palm. The goal for this work was to perform a review of the state of knowledge of mangroves in the Jalisco coastlines and analyzing the main changes in the coastal landscape, particularly for the mangroves in Jalisco. In order to do this checkup, it was necessary to consult the database from Guadalajara University, publications in Google Scholar, and the charts from CONADE. As a result from the consultation of all of these different databases, we found 26 research works distributed in 5 main topics. 50% of the consulted works were done regarding the Salado area. The type of publications were 5 different ones: dissertation, articles, extension, and book chapters, out of which the dissertation had the highest number of publications, followed by a journal and magazine articles. Out of all 26 research papers, which took place in different areas of the Jalisco coastline, such as the Lagoon Chola from Palama, Estela Majahuas, Estela La Manzanilla from El Salado, as well as the Lagoon of Barra and Navidad. The El Salado was the one that presented the biggest number of publications with 13, followed by the Navarro de Navidad Lagoon publication and the Manzanillo State one with 5. This research and investigation focused in different areas, such as taxonomy of associated species, primary activity, forestal structure, ecophysiology, mangrove species, environmental determination and condition, change of use of soil, and biodiversity associated. The points of study with the biggest number of publications were the ones for associated diversity, forestal infrastructure, and primary productivity. The state of El Salado is found in the Puerto Vallarta municipality, which has an extension of 135 hectares of mangrove. It is an area that is fragmented by hotel development, living quarters, and coast. However, it is the most studied mangrove area in the state of Jalisco. 3 different surveys and studies have happened in the past decades. The studies are sort of aspects of the infrastructure, production of the jarasca, production of biomass, biodiversity of the stereo, and environmental condition and assessment. Some of them are also related to some of the different animals, such as birds and fishes that might inhabit it. The anthropic activities are a menace for these ecosystems. This influence in the coverage or the perturbation of the mangrove. There are 2 different types of anthropic stages, the agricultural and livestock. The first one is related to the use of soil and the activities, such as, for example, livestock, agriculture, and silviculture. Now, regarding the anthropic development, this is also related to the use of soil. However, it has a different focus, such as, for example, the use in rural areas, in urban areas, in industrial areas, touristic infrastructure, and ports. In accordance to the update and the use of the monitoring system done by the National Commission for the Knowledge and Use of Biodiversity, they signal that in total, mangroves lost 5,858 hectares in the last assessment periods between 2005-2010 and 2010-2015. They record winnings of 25 to 23 hectares. The biggest loss was of 1,850 to 2005. The investigation regarding Jalisco's mangroves is very incipient, which is why it's very important to establish some research lines in order to calculate the storage capacity for carbon, as well as the mitigation capacity for adapting to climate change effects. Well, thank you so much. Are there any questions from our audience? Please, everyone who's listening in, make your questions known through the platform. We're going to give a couple of minutes for some questions. So, Maria, what's the future of mangrove studies in Jalisco? What are the main research lines you believe should be developed? Well, I think that the main research lines should be investigating ecosystemic systems, as well as blue carbon. And I believe that here in Jalisco, we're currently sleepwalking regarding mangroves. And I believe that Jalisco has a lot of potential to really do research, because there are a lot of students, mainly they should be the most motivated ones in order to continue working on these workflow lines and research lines. So I think firstly, we need to know and understand the mangroves we have here in the state, understanding everything they offer us, in order to afterwards start opening different lines. Are you a student? I'm a natural resource engineer student. Is it your undergraduate degree? Yes. Great. So you are the ones who have the power. You students are the ones who have the power of deciding the areas for investigating. The dissertations for undergraduate students are one of the most important tools for starting these lines of studies and defining the different findings. It's necessary for more and more students to join in this type of studies in order to really get to understand this type of ecosystem, such as mangroves. Because we've seen and mentioned 1,000 times the different value, ecologic, and everything that it generates for the maintenance of the ecosystem. So let's hope that this work can work as a call for helping students, researchers to work as a group in a place such as Jalisco, because Jalisco is very good in this. We need to pay more attention to Jalisco's mangroves. I want to congratulate you, and let's just give a couple of minutes in case. Oh, actually, I think let's just give one more minute for the next presentation. Thank you very much for your participation. Thank you.
Adelante, doctor Carlos.
Continuando con el programa, tendremos el trabajo línea del tiempo en investigación y conservación.
So continuing with today's program, we will now be looking at the timeline in research and conservation of mangroves in Mexico, future perspectives. This is going to be given by Ochea Gomez Jonathan, Felix Pico Esteban, and Acosta Velasquez Joanna. So we have 15 minutes. Thank you. Thank you and good morning. I'm going to be presenting a review that we're taking place and I hope that you enjoy it. Today is time for the documentation of preservation processes for mangroves in Mexico. I'm Jonathan Ochoa Gomez, Felix Pico, and Joanna Costa. So in mangroves, we have 58, which was the first report for the distribution limit in North America. And it says that Maria de los Angeles is the limit of distribution for the mangrove. Afterwards, in 74, Rolig did a first study for ecology, recognizing different mangroves in Mexico. In 1981, Victor said that there was some research to be done regarding the hojarasca production, and they did some studies in the different zones. In 85 to 89, Jorge López Portillo, Ezequieles Rubia did a study for productivity in the response in the output of mangroves in Tabasco. At the end of the 80s, also Francisco Suarez Ovasco was collaborating with different studies in the productivity in the mangroves of Sinaloa. So in this context, the first report at a global level is the one from Bothman when they talk about the physiology and existence of the red mangrove, and they do it from the Academic Literature Philosophy Academy. And unlike some other ecologists from humanity or different natures, they started working on this type of ecosystem. Therefore, we generated the Odudian type of plants that provided a lot of knowledge to the functioning of this ecosystem. Bram, Quillick, and Cognizant will later on continue with the research in this system by performing carbon studies regarding the input that these might have, or the input that these ecosystems might have for the coastal carbon input. And also in 1986, a very famous book called Atenta del Mar for the mangroves was published. Then we come in the 90s, Francisco Bregas and collaborators could generate a very important study that really became as a breaker that talks about the management of mangroves, their productivity. And afterwards, Guadalupe Nevasco that really looks back in the coastal lagoons in the Mexican littoral that they do with along with Jorge Cázares Martinez. In 1995, 1996, and the end of the 90s in general, the group of Louisiana at the State Louisiana University, made up by John Date, Robert Trill, and Victor Herrera, they started generating knowledge regarding the different nutrients, productivity of mangroves, their structure, particularly in some of the terms. At the end of the 90s, Alejandro Robes Arancile and some of his collaborators published an article regarding mangroves and their importance for climate change. In 1999, Cristian Tobilla and Guadalupe de la Ardanza did the first campus erect study in Mexico talking about their ecology. Arturo Ruiz Luna, Cesar Aidana Robles did the first change study focusing in a coastal lagoon with mangroves in Sinaloa. At a global level, we also saw a lot of big inputs regarding the knowledge and understanding of mangrove with Sneed III, Twilly, Nita Seller, Catherine Newell, from different perspective of nutrients, ecosystemic systems, productivity levels that really drove forward to continue these research lines in those years. It was in the year 2000 that Jorge Rueda Silva and Arturo Jimenez did the first structure system in Yucatan from their mangroves. And in 2002, Jorge López Portina, Ezequiel Escurra did this very famous review of mangroves in Mexico, where they say exactly where mangroves are regarding knowledge and importance. In 2004, in the postgraduate school focused on forestal management started reporting what is happening with the rates that might be used for different mangroves roles in the Nayarit area. In upcoming year, the first report regarding the mangrove Conavio program was published, and another of the most important articles regarding mangrove history in Mexico was posted for the factors that conditioned the growth of coastal mangroves, which was the hydrology and topography. Luis Luna and Acosta Velázquez, along with Malanga Robles in 2008, made the first review of the coverage of mangroves in Mexico, and in the same year, they published an article regarding in the National Academy of Science where they mentioned the relation they have with the society, but with a very different type of perspective. In 2009, Conavio published the first book of mangroves in Mexico, focusing on the extension and distribution of this type of ecosystem. On the same decade, the knowledge regarding mangroves was driven forward regarding the Brasham by Jeff Bashan group in Ziploc, where he became the global pioneer regarding microbiotic and the symbiotic relation that this microbiotic has with mangroves ecosystem and the positive effect that they might have in the restoration of mangroves. He, along with Gina Belin, were the first at a world level in the same decade to focus on that. Ivan Balena launched an article regarding the concern they have for this forest and the fact that they need to be preserved. In 2002, and a little bit before 2002, Alonki was already talking about the synergy and the energy flow in this type of ecosystem. In 2003, the first cardboard cut back and everybody started looking at these coastal humid areas where they were mentioned that they have a massive capacity of kidnapping carbon dioxide. Other authors also drove forward from the study of the increase in the ocean level and the potential that the mangroves and this type of systems might have to prove resilient to this, and what would happen if we had no mangroves. We also pushed forward a lot of the subjects for the study of mangroves. Afterwards, in 2010, Aldivar Jimenez, who was an collaborator, became the first in the context of the conservation of mangroves in the Yucatan Peninsula. And in 2011, the first white carbon report at a national level. Ignacio Valdez was the one who generated it. In 2013 and afterwards, they began to have a different way and methodology for generating information, which would put the Mexican mangroves in the world map that are playing a fundamental role, since we already knew that because we're the fourth place at a world level in coverage. However, they played a very important part in carbon recovery. So looking back at all of the recap that they did for the distribution of mangroves, Acosta Velázquez and Rodriguez Zúñiga, generating an assessment of the coverage level between 1970 to 2005. Afterwards, in 2016, Edwin Silveira and others did a research and investigation of the level of carbon in Mexico. Paola Escurra likewise said that the coastal disposition and the temperature would increase if there weren't any type of mangroves and other tropical. Likewise, in the same decade, in 2019, Jonathan Ochoa did an assessment of ecosystem services regarding the structural capacity, physiographical and hydrological capacities of the mangrove. The same year, Vasquez Nulle and others did the first manipulation of the Mexican mangrove study. They also generated a lot of information and knowledge regarding the ecology of mangroves, focused on the storage of carbon. The timeline and preservation and investigation was the first one that ever took place. Semanar, in order to become Semarnat, which is the Ministry of the Environment, happened in case of the studies. They generated and studied different mangroves in Tapachula in 2003. Afterwards, a follow-up of these workshops took place up to 2008. A year before 2008, 60% in order to protect mangroves was issued this article that had been a standard since 2002, and special projects began to be developed. In 2011, the CONAM and the CONADEP started to agree on how can we preserve this ecosystem. In 2012, the Climate Change General Law was issued, and different congresses of mangroves began to take place a little bit before 2010. The first one took place, and in 2012 was the second. In 2014 was the third one in Vallarta. In 2016, the expert lines in order to generate methodology of how to study mangroves began to change. 2018 was very important because of the payment for environmental stuff. It was developed, and fortunately in 2020 we have the Mexican Congress for Mangroves, even though it is virtual. So it's very important to see all of the developments from the perspective. Thank you very much. This is everything from Dr. Sarancilla, la doctora Guadalupe Pavance Espino, of course, Dr. Francisco López Verdugo, Dr. Jorge López Portillo, Dr. Víctor Herrera Monroy, Dr. Jonserrat Terreira, Dr. Cristian Rodilla, Dr. Artilla Luis Bonilla. Their efforts have been seen all throughout the nation in different organizations, and the future perspective are very varied. However, we would like to focus in order to characterize mainly the zonification of ecosystemic system, the knowledge and reformulation of public policies of these ecosystems, and to start to analyze such services in. This is a quick review of the timeline regarding investigation, research, and conservation of mangroves in Mexico, and I would like to now invite you to collaborate, to whoever wishes to join in this effort. Thank you very much for your attention. Well, thank you very much for that history lesson. I don't see any questions so far from the audience, so let's just wait for a couple of seconds to see if anybody writes one. Okay, so we will now continue with the following presentation. I would like to ask, well, before we continue, if there are no questions, I would like to use the rest of the time that I have allocated in order to make a couple of comments, if that's okay with you. Yes, of course. Great, thank you, Doctor. So this work is being directed by Dr. Carmen University. And I am the director of a company called Aura on the coast. And we would like to invite everyone for different types of mangroves in Mexico to do this review. We have worked a lot on this. We are quite ahead on the work. However, we would like to invite anyone to join in order to be able to replicate this enthusiasm and this effort for more people to be able to join hands on this. And also we think it's very important for 2020 to have this in order to see what's coming up ahead regarding blue cardboard and the mangroves in the country. If there are no more questions, then I would kindly like to invite you to write to us so that we can continue working together on this workspace. The best of lucks, and hopefully a lot of our colleagues will join this effort and will be able to work hard, but everyone together and cover more. So thank you very much, and we'll be back in a minute.
Carlos.
Bueno, pues les comunico que desgraciadamente
I would just like to communicate that unfortunately the following member of our panel wasn't able to join us and send her video. Therefore, this morning table for conservation and management is concluded. We will now take a break until 1 p.m. when we will listen to the next key conference given by Dr. Ezequiel Escura from the University of California, Riverside. Hopefully, you will all be able to join us for this conference. Thank you very much and bon appetit.
buenas tardes a todas las personas que participan al quinto Congreso Mexicano de
everyone who is participating in this 5th Congress on the mangrove ecosystem. Good afternoon, everyone joining us in this 5th Mexican Congress of the Mangrove Ecosystem Tabasco 2020. In order to continue with the activities of the day, I want to introduce our next speaker, Dr. Ezequiel Escurra, an ecologist and professor of the Department of Botanics in the University of California in Riverside. He has more than 300 publications, articles, books, chapters of books, essays, and film scripts. He has worked on research regarding community ecology, as well as vegetation in arid zones. Dr. Escurra has been head director of research institutions in Mexico and California. He has also received national and international awards for his wonderful job for the preservation of the environment and for the scientific international cooperation. We want to welcome Dr. Ezequiel Escurra, and we invite him to give his keynote presentation. You have 50 minutes for the presentation, and we have 10 minutes for the Q&A session. Thank you very much, Ophelia, and good afternoon, everyone. Can you all hear me? Yes, we hear you just fine. Well, good afternoon, everyone. It is truly an honor to be in this meeting and to participate in the really important Congress. For me, it's an honor, and it's a reason to feel humble, because I see the list and the names of the speakers that we have, and it's outstanding. We have great researchers, international, like Boone Kaufman, and the most recognized researchers that we have in Mexico that have a career, a really long career in studying wetlands, like Patricia Moreno Casasola, Jorge López Portillo, and young Mexican researchers as well that are in the peak of their careers, and many of them just starting their research career. And this morning I was listening to the presentations, and it is truly, I mean, it is really enriching to see the amount of young people that are involved and doing many things. Some of them in their bachelor's degree or in postgraduate studies, and they are working in great projects with mangroves. And when Maribel invited me to give a presentation here, and especially after looking at the list, this scary list with great names, I thought, what can I say that they won't say, and maybe even in a better way than myself. We have great speakers, so I thought about talking about a topic that I developed over a year ago for a conference called Miguel Alemán that I gave in Mexico City, and it was a reflection on the rise of the sea level and how we can use the information that is contained in our coast forest of mangroves to understand the magnitude of this phenomenon. So I will start by sharing my screen. I hope you can see it. And actually, the topic is about understanding what the mangroves can tell us about the rise of the sea level. You have all heard about the rising of the sea level. Some social groups say that this is extremely concerning. Others, the skeptical groups to climate change, say that it's not so worrying. But for instance, this is a map that I got from the most recent report on the climate change panel, the IPCC. In red, we can see all the places where the rise of the sea level, these are currently land surfaces, and the rise of the sea level puts these ecosystems in danger. And we can see all the islands here in the Polynesia and in the southeast of Asia that are at great risk. The country of Bangladesh and part of the delta of the Indus River, and we can see here the delta of the Amazonas and the Orinoco River, and we see in Mexico some spots in red that are highlighted as risky areas due to the rise of the sea level. Now, trying to make some sense about it, first I would like to make a quick reflection on how the level of the sea has changed after the final ice age, the Wisconsin era, about 15,000 years ago. The sea used to be 100 meters below what it is right now. And although this seems unrelated to mangroves, please bear with me. I will connect it to our topic. But this is an article published in the Science magazine by a group of researchers, Mexicans, and also one researcher from Venezuela, as well as other researchers from the United States on the findings. In this diagram, you can see that this is the Hoyo Negro cavern. This is a place in the state of Quintana Roo. The bottom is 40 meters below the phreatic level, and it matches the sea level. And below that cavern, they found some remainings of the wildlife of the Pleistocene, the pachyderms, giant sloths, and humans as well. They found the skull of a young woman, 15-year-old woman. She was called Naya. And since the finding of Naya, we were able to extract some pulp of the teeth and to have accurate information of the DNA of the first inhabitants of the American continent about 12,000 years ago, after the ice melted. But what I want to highlight here is that 12,000 years ago, the level of the sea was around 80 meters below of what it is now. That's why exploring this cavern was so complex, because you have to dive 40 meters into the phreatic level to get to these deep sites, and this implies that you need all the special equipment and a specific type of specialized diving. But it is important to note that 12,000 years ago, the sea was 18 meters below of what it is now. And this matches with what has been found through many researchers with the data obtained from coral reefs. 20,000 years ago, we can see where the sea level was located, around 120 meters below what it is now. And 15,000 years ago, it started rising quite rapidly until it got to 8,000 years ago, where it got stabilized in the level that it currently has in this Oligocene era. So the sea has been rising in the past 15,000 years, and in this period, it grew quite rapidly at a rate of approximately 1 to 2 centimeters per year, according to this. And this is quite high, quite rapid. A century ago, it even rose like 1 meter or 2 meters. So the first inhabitants of the American continent, throughout their lifetime, they were able to observe these environmental changes, the mangroves flooded by this rapid rise of the sea level. But like 80,000 years ago, this got stabilized. We got to the interglacier period, the starting of the Oligocene era, and the rise of the sea level got stabilized. But this means that it didn't got any higher? Well, no. What we have found, thanks to the mangroves, is that since the classic Mesoamerican era, like 1500 years ago, or those that have an European vision of the time passing, since the uprising of the Roman Empire, the sea has been increasing its level, perhaps in a different rate, but it is rising. And here we can see the sediments of a forest and black mangrove forest, quite short in Baja California. And we can see that we're taking a sediment sample with the purpose of calculating blue carbon, and 50 centimeters below the mud, below this mud, that is the product of the organic matter and the clay mixture created by the crabs. And we can see that there's a layer of organic tissue. We can see that these are roots that are not decomposed. And in botanics, this is anaerobic remains that are not decomposed. And this is quietly identified here. You can see here on the top the remains of this matter from different parts of the mangroves of Baja California. And here we can see a sample, a microscopic sample of this layer of peat. And then we have a sample of these rhizophori roots and the mangroves that are making this peat on the bottom of this layer of mud, and they are accumulating large amounts of peat. Is the black mangrove that gets deep into the ground and grows while the sea level is rising. Using these techniques for carbon-14 analysis, we can calculate the age. Here we can see a chart of depth in current times, and we're going back like 1600 years ago, during the collapse of the Roman Empire, and when the medieval times started, to put it on an European scale, or when the classic Mesoamerican era began. And since then, this peat has risen like 1.5 meters, and these a little bit less than that, but it gives us a rate of 0.7, 0.8, less than 1 millimeter a year. The point here is that if in the last interglacier era, 8,000 years ago, the rising of the sea level got stable, the data from the mangroves, because this is data from different lagoons in Baja California, we have the coastal lagoons in Chiapas, also national marshes, as well as other spots. As we can see, the correlation is quite accurate. And mangroves tell us how rapid the sea level has risen. And since the collapse of the Roman Empire, the sea used to be 1.5 meters below. We can even project this to the peak of the Roman Empire on year 0 of the Common Era. And the sea used to be 2 meters below of what it is now. So this explains many of the things and why the Roman ports that were built with the materials that the Romans used, we are able to find these remains, archaeological remains of these materials 2 meters below the sea level. And also we have cities like Venice that are suffering from this impact, because the sea has risen a lot, maybe in a slower rate now, but it has in the past 2,000 years. Now, the theory tells us that in the 20th century, and the theorians say that since the Industrial Revolution in the 19th century, and especially in the 20th century, the rising of the sea level has increased because the greenhouse gases have been accumulated in the atmosphere, and the melting of the ice and the poles has increased as well. So we were able to measure this many years ago, well, 12, 13 years ago, with a great colleague from the Autonomous University of Morelos, Javier Lopez Medellin, and we were able to obtain a really accurate estimate on how much the sea level has risen since the mid of the 20th century and up to today. This is part of an article that we published on the anomalies, oceanographic anomalies, and the sea level rise marked by the mangrove communities. These data, where I am pointing now, this is data from six marographers in Ensenada, in Los Cabos, in Mazatlan. All of this data is giving us an estimated average on how much the rise of the sea level has changed in the Pacific coastline. And what we can observe here is that this oscillates, it goes up and down as if it was some sort of EKG. So this is like in the summer and winter. In summer, the water gets heated, so it expands. So there's a natural oscillation in the level of the water between summertime and wintertime. But in some years, we can see that the rise during summer, it's quite higher than in other years. And this is due, this anomaly is correlated with the multivariate oscillation variable, which is the years of El Nino. When the sea gets hotter, then the sea level can get up to 300 millimeters, 35 centimeters, and that's quite a lot. That's more than 1 foot. In American units, it's even greater than usual. And besides that, we can see quite well how the trend goes up. We can see the straight line is the global trend. So we have 3 different phenomena: the change between summer and winter, the impact of El Nino, and the general trend that is marked by the slope of that straight line tells us that the sea level has been rising approximately 2 millimeters a year. And let me go back. I told you that since the beginning of the Common Era, since year 0 of our era to the 19th century, the roots of the peats in the mangroves tell us that the sea has risen 0.7 millimeters a year. But by mid of the 20th century, that accelerated to 2 millimeters a year. Mangroves tell us this story quite well. This is an aerial image that we got from a Mexican aerophotography company of the mangroves in Bahia Magdalena. And check where I'm pointing now, you can see how it changes when I move from one image to the other. You can see it quite clearly. There it is. I'm sorry, there it is. This is the image from 1966, and this is the image from 2010. You can see quite well that the coverage of the mangrove has increased, and this is quite intriguing. I'm always writing articles saying that mangroves are in danger. However, the aerial imaging shows us that the coverage of mangroves has increased here. This is a digital analysis of both images superposed, and everything in red is all the places that seem to be covered by mangroves when in reality 60 years ago this was covered by vegetation. And what we see in blue are places that used to have mangroves 60 years ago and that have lost it. You don't need to be a genius to realize that the borders here, the mangrove is receding, and inland the mangrove is increasing, it is growing. So we went to the field, we took the topography team, and we corroborated exactly what we are saying now. This is a mangrove where you can appreciate that the red mangrove has been lost in Bahía Magdalena, Baja California. And here we can see the erosion caused by the rising of the sea level. This is Dr. Escurra. This is myself with measuring with the topography equipment and measuring the topographic level. And we can see that places that 60 years ago used to have vegetation and there were salt mines are now flooded twice a day. The sea is rising, and you can see the result of the rising of the sea level, that the mangroves are growing inland. And this is what we can observe from the satellite image. That spectral image, you can see it there. It is growing, yes, but this doesn't mean that it's not a tragedy what is happening with climate change, because these new mangroves, we can see them as mangroves, but they don't grow so much in 60 years. They are quite short. In Baja California, the mangroves, they can have 200, 300 years of age, and they are only 4 or 5 meters high. The growth in the West Coast, the analysis of carbon-14 tells us that it's quite slow. So what mangroves are telling us is that the rising of the sea level in the past 60 years has accelerated once again to 2 millimeters per year approximately, and the mangroves are responding. If there were no mangroves there, this coast would be eroding quite rapidly. So this tells us that this is an important environmental service, but it is quite difficult. Because the change is faster. So these new mangroves can be appreciated quite clearly because these are seedlings, these are young plants. They are not adult trees yet. Is that important? Does this have an economic and ecological impact when the sea level rises, especially when we talk about the mangroves? And I always like to show this image. This is a road in Baja California close to the coastline. It goes to a fishing community called Playa Cancun. It has nothing to do with Cancun, but that's how they called it. And you can see that the road was passing through here, and after El Nino in 1988, the sea level rose a lot and the road got waterlogged, so they had to create a new one. And the mangroves started growing here. Actually, this image is from 20 years ago, and currently the road has been erased completely. And it's interesting because you ask children in this fishing camp, those that are 15 or younger, if they believed me that the road was a straight line going through here. And now we have wetlands there, and they do not believe it. They cannot imagine that the road was a straight line. They always thought that the road had this shape. And this is very interesting because 30 years ago, that area that is now covered by mangrove and that gets flooded twice a day, 30 years ago, it was a place like this one on the top. So the rise of the sea level is now producing, and it is quite clearly that changes are happening on the coastline. This image is from Gael Almeida, the director of National Geographic Mexico, who took this picture in 1998 from the NH Hotel in Cancun. You can see the beach, the famous beach of Cancun, in front of the Hotel NH. And in 2008, she took the same picture. And if you realize, the beach has been completely disappearing because they are building now more buildings. It was protected by mangroves in the past, and the sea level has risen, and all the hurricanes and the intensity of the climate anomalies led to this new landscape, these nightmare landscapes. The government is extracting sand wherever they can. and fishermen want to stop this damaging. Many years ago, we worked with Octavio Aburto, a biologist, a great colleague of mine, and we found that these mangroves on the border, the Rhizophora mangle, play an important role for the recruiting of open sea fish. They stay here in the mangroves throughout their lifetime, and they become an important part of the fishing market for Mexico. And we found that for each area, we calculated the amount of mangroves and the amount of fisheries, and we found that all the fisheries that are associated to the mangroves, and there are many, we have many types of fish, many species, also shrimp and other type of fish can be found here in the mangroves. And look at the correlation between the mangroves and the Rhizophora mangle species in these coastal lagoons by these sectors and the tons of fisheries and the income that it represents for the fishermen, millions of dollars. So from the fishing point of view, the role of mangroves is essential. But now let me go to one of the most important mangroves, national marshes, quite famous for these straight line parallel marshes. A lot of research has been done on these areas, and I cannot get into detail because I don't have enough time, but we can see these growth lines. It's like the rings on a tree, and these have a frequency of 12, 15 years, and it has been produced by the rivers that bring the sediments to the coast, and they are redeposited throughout the coast. And some rivers, like the river Santiago and the Rio Fuerte on the north, have been contained. And in these rivers, when the sediments do not reach the ocean, the coast recedes quite rapidly. We can see that in red. And those rivers that are not dammed, like Acaponeta or San Pedro, River San Pedro is in Nayarit. It's not River San Pedro in Tabasco. These rivers that are not contained, we can see a growth in the coastline, quite slowly, but it is growing. And those rivers that have dams, the coastline is collapsing. The difference when you visit them, it's amazing. You can see in San Pedro these tropical forests typical of the Pacific with really healthy mangroves that are growing. And opposite, we have River Santiago that looks like this. It is receding 150 meters a year. A lot of trees are dying. So it is an apocalyptic scenario here. The same thing happening on the River Fuerte. You cannot see very clearly, but you can see the trunks there of Avicennia germinal, the black mangrove. In summary, what we know is that in the places where mangroves are healthy, the sediments, where the rivers are healthy, where there are no dams, then the mangroves are healthy as well, and the sediments protect the coastline. This is really important for Tabasco because Tabasco also has a large amount of these mangroves and sediments coming from the Grijalba-Usumacinta basin into the Valley of Mexico. In the rivers with dams, we can observe the coastline receding, the mangroves dying, then the black forest exposed to the water, and a catastrophic scenario. This tells us how important the interaction is. Climate change and the sea level rise, and what we do, what humans do inland. I am certain, because I have seen this in the study of environmental impact for the Aguamilpa Dam. Nobody made the question of what is going to happen with the national marshes or in the coastline if you have a dam here in this river that is 200 and 300 meters away from the coast. But the impact is quite high. It is astonishingly high. And now, let me explain something that I hope that really gets to your heart, to all of those that live in the southeast of Mexico. This is a story that belongs to Carlos Burelo. Once he wrote and he said, you have to go and visit the mangroves in San Pedro Martir. I never believed what he said. He said that 200 meters away from the border between Tenosique and Guatemala, there were red mangroves. But when we went there, we were shocked to see how a freshwater river can have these large amounts of red mangrove. And red mangroves are astonishingly to see here. This is the lagoon of El Cacahuate, close to the Mesoamerican University, and you can see the dense formations of red mangrove. It is a spectacular landscape, and I think that people from Tabasco, after the dramatic destruction of the jungle, they have these remains of forest around San Pedro and in this mangrove. So we have to do something about it. We need to protect them because it's a valuable ecosystem, and it is a good opportunity to study them as well. We can see different species like this one that belong to the coast, and you can find them there. So we do not only have red mangroves, but the full ecosystem that goes with it. We can see a Corsicarium. We can see the flowers here. It is worth to visit. We took samples of the leaves as well on the mangroves around the peninsula. And we found that the mangroves around River San Pedro, you can observe here the gradient of the mangroves in the River San Pedro and Laguna de Terminos. And you can see this is Celestún, then we have Chetumal and Mahahual, the Gulf of Mexico, the northern part of the peninsula, and then the Caribbean, forming this shape. And you can see that in River San Pedro, and you can observe that here, it is really close to Laguna de Terminos. And River San Pedro is 20 meters higher than the sea level. So how did the propagules coming from the Laguna de Terminos, how did they get there? They are usually dispersed by water. How did they make it up to the river? And after a lot of thought, the analysis tells us that they got there like 150,000 years ago. And 120,000 years ago, the situation was, this is the amount of carbon dioxide. We were in the midst of another heat wave in an interglacial era. You can observe this. This is the current time. About 100,000 years ago, we had the Wisconsin period, the final ice age, and 150,000 years ago, there was the final interglacial era, where the temperature was quite higher, even higher than it is now. In this era, the concentration of carbon dioxide and temperature increased a lot, and the evidence shown by the researchers that work in the Antarctica, during winter, the poles were completely melted and the sea rose like 15 meters than it is now. And you can observe this in the presence of these Emian terraces in Valdivia, Chile. You can see these terraces with the sea sediments like 10 meters above the current level, or in the Bahamas, you can see these coral formations 15 meters higher than the current level. And when we analyze this with radioactive isotopes, you can find that they have an age of 130,000 years. Here, I just want to speak very briefly about this, because we know all of this thanks to this character. And I always show his picture because he was like a nerdy type of man in the way he behaved, and he was a great Croatian scientist. He dressed quite formally. Milankovitch, and he elaborated the theory of the Pleistocene cycles. he published this in Serbian, so nobody read it until 30 years ago when someone realized that Milankovic had a really clear idea on what was causing the glacier eras. Is due to the eccentricity of the Earth's orbit and the tilt of the Earth's axis and variations when autumn happens around this eccentricity of the orbit, which is called as the equinoccio. And this happens with great timing every 120,000 years that leads to the ice age. So we know what causes the ice age, but perhaps the propagules of the Terminus Lagoon got into this river of San Pedro like 120,000 years ago. So we did a simulation with different levels of flooding from the peninsula of Yucatan and the coast of Tabasco in the Gulf. And yes, with a flooding of 10 to 15 meters, the level gets perfectly to the reform cascades in River San Pedro, and the mangroves could have flooded the river perfectly. Once in the River San Pedro, the mangroves got dispersed through the geology of the peninsula. We can see the ending of this karstic shield in Yucatan and the beginning of these terraces of the Pleistocene, and you can see here the land of Tabasco, of the cities in Tabasco. And Carlos Burelo and his students have always helped us on the field, and they have shared their knowledge because they really know this area. So it is always a pleasure to go on field with them. You can see here the deposits. You can see here in Balancan, this is the main supplier of clay for the region. This is a well also where we found, and you can observe here in these images, remains of oysters, identical to the Crassostrea, the current one. And this tells us that the sea got to these levels. It got to these cascades 130,000 years ago, and a lagoon was there. So what we know is that mangroves are moving a lot with the changes in the sea level. And in the final ice age, they got to the current cascades in Reforma, and then they receded once again to the current sea level. Probably they went even lower than that because during the peak of the Pleistocene, like 20, 30,000 years ago, the sea used to be 100 meters below where it is, and it has gone up until its current level. And many things are worth mentioning here. All the studies on the sea level rise have been performed with coral reefs and also with the ice that are found in the Arctic poles and in the Antarctica. But mangroves are a huge source of information on our story, on our background, where the sea level was in the past and in different time scales. I hope that I was able to convince you that in these 130,000 years, we have gone to a rise and then a descent in the final ice age, and then to the current situation, and we got to this sea level that we have right now. If mangroves have been able to follow these changes in the coastline, then it means that we should not be so concerned about the changes in the current sea level. Well, in many places, I think that the mangroves will be part of these changes if it happens at a rate of 2-3 millimeters a year, because that's what they did when the sea level rose by the end of the Pleistocene, like 15, 16,000 years ago, where the sea was rising even 1 millimeter. But we have to be cautious. This is the amount of carbon dioxide in the atmosphere in the past 400,000 years. You can see the cycles: glacier, interglacier, glacier, interglacier, then glacier, and then the Great Glacier and Ice Age that took place like 120, 130,000 years ago in the Wisconsin era, and this present time. We can observe in green the appearance of the Homo sapiens in this happened like 1,000 years ago. And if we exaggerate this, how fast the carbon dioxide level has grown, it is close to 400 parts per million in the atmosphere. And in the last ice age, it was like 270 parts per million. So basically, this tells us that this species, this Homo sapiens species, is responsible for what is happening. It is up to us to preserve the coastline and to preserve the sea level by decreasing and by stopping perhaps greenhouse gases. It is really concerning when we see it that way. When we see the geological scale, it is concerning to see what's happening, because in the past, carbon dioxide was a product of climate change. And now, thanks to our emissions, or through our emissions, climate change is the result of what we are doing throughout these emissions. And the change is here to stay. I showed you some images of Cancun. This is Miami. A few years ago, this never happened, but now it regularly gets flooded. And I showed you images from Bahia Magdalena in Baja California, and this is the delta of the Mississippi. As you can see, the channels are quite clear 50 years ago and how they look now. The delta of the Mississippi is receding quite rapidly, and the vegetation as well, it has been unable to compensate for the rise of the sea level. I'm going to stop right there. We have a few minutes. I'm sorry if I went too fast, but I want to thank my university and the Scripps University of Oceanography. They have worked with me, and also on the center, here's the University of Juarez of Tabasco. And I want to thank many people. I have great friends in the university, Ophelia, who introduced me. I was her teacher during her PhD, and also Carlos Borello, and all his students that have great knowledge on the area. And all of those that have collaborated with me in different moments, in different expeditions to make all of these things. I'm not going to give you all the names because it would take me a long time. Even during Christmas, we celebrate in the mangroves in different places in Mexico, exploring. The people from the University of California in LA, the team of Felipe Zapata, Claudia Enriquez, the ones that are doing the molecular analysis of the DNA, Octavio Aburto from Scripps. And I also owe a lot of my experience to this dear friend of mine, Jorge Lopez Portillo. Last year, actually, I was able to revisit the transects where he did one of his first works on the mangrove productivity. And of course, the people from Tabasco who always join me on my expeditions and adventures on the mangroves. Thank you everyone for your attention, and I am ready for the questions if there are any. Yes, we have several questions now, and also people that want to congratulate you. I will begin with one of the questions. Dr. Juan Zavala Cruz is asking, how did you explain the receding of the mangroves close to the mouth of River San Pedro if River Usumacinta has no dams? Were you able to hear me? Yes. Well, perhaps I didn't explain myself. I imagine, well, I don't know. He's saying that in the mouth of River San Pedro, that leads to Laguna de Terminos. Is that what he's saying? Because I am mixed up with all the rivers San Pedro. There are several. We have rivers San Pedro Mezquital in Balancan, and we have river San Pedro Mártir, and San Pedro Mezquital in Nayarit. So I don't really understand. It's the river San Pedro of the Cascade of Reforma. When we see, this is the river that comes from Guatemala. Well, I said, I haven't really studied the mouth of these great rivers, Grijalva, Usumacinta, and then in the lagoon and in the estuary of Usumacinta. And what I mentioned, and perhaps it was misunderstood, but Tabasco has some beaches there the same way as Nayarit has. There are really interesting formations there. All the port of Dos Bocas was built on this sandy area with the border mangroves. What I wanted to say is that we need to be cautious, because if we stop the arrival of sediments of the sea, like it has happened in Nayarit, they are quite fragile and they get destroyed, and it will depend on the feeding of sediments on the coastline. But I have no evidence saying that in this area of Tabasco are receding. The great tragedy there that at least the ones that we have documented, is in Nayarit. And this leads to a second question. The presence of mangroves in rivers San Pedro and Balancan, Tenosique could be related then with evaporate rocks from this karstic zone? Yes, it's really interesting. That question was really interesting, and we have evidence. And if you want to really get into the study of physiology, for some reason, the red mangrove, Rhizophora mangle, is not necessarily marine, although it lives in the sea water. There are many places in the Caribbean, as well as in the Pacific Islands, in Polynesia, and also in the Caribbean and the Mexican coastline, where the mangroves grow in fresh water. For example, in the Reserve of Sillancan, it is filled with the short mangrove that grows in fresh water, but it is saturated by calcium carbonate. My intuitive explanation of this tells me that red mangrove, and we know this because it has been studied, excludes salts on a root level. So it excludes the salt on the roots. It has a great mechanism that allows it to exclude the salts, unlike the black mangrove that brings the sea into the roots, and then it eliminates the salts through specialized glands on the leaves. So it gives me the impression, we have the idea that the selection mechanism of salts on our root level allows the red mangrove, the Rhizophora mangle, to live, to survive in water that is saturated with calcium. But this is only an intuition. We have not put this to the test. This is based on observation. There are many places with fresh water, but always saturated with calcium. And this is where we can find the red mangrove. For instance, the studies of Ariel in Bahamas 50 years ago, with clear samples that show us that in interior lagoons, if there is water with calcium saturation, then the red mangrove can grow. So once the mangrove got to the river San Pedro, stayed there because the water runs on the calcarean shield, and water is saturated with calcium, as we can see with these channels around the river. So the key element of the survival of the red mangrove in River San Pedro comes from the water that's calcium saturated, and also the sediments, because when we come from the Cascades and into the river and it gets closer to the Usumacinta River on a bed of mud, then there are no more red mangroves there. We cannot find them in the Usumacinta River, and then it reappears close to the coastline in the Gulf of Mexico. Now we have one question from your student, Jorge Lopez Portillo. My dear Jorge, hello. Taking into account the fluctuations of the sea level as of today, how old are the sediments of the mangroves in the Gulf of Mexico and the Caribbean? How old are the sediments of the mangroves in the Gulf of Mexico and the Caribbean? That's an excellent question from the student to the teacher. And actually, I do not have an answer. I don't have a smart answer to that. It is still something that we have asked and we are trying to unravel. Why in some coast lagoons do we find mangroves growing on their own peat? And sometimes you find 4 or 5 meters of peat. And the work of Karen McGee in certain keys of the Caribbean, in Belize, they have found like 20 meters of peat below the mangrove. So the mangrove has maintained on the same level and it grows on its own peat. But in other areas, if you make a hole, sometimes you find no peat under there. And if you find it, it's only like half a meter or 20 centimeters. And then you see the original rock. Usually we find remains of shells from the Pleistocene, and we still haven't figured out that yet. I think it's related to the slope in the coastline, and it is likely to have something similar in the Gulf of Mexico. And it has to be in areas where the coast is sloped. In areas where the slope is not that big, then the mangroves grow inwards and outwards throughout the Pleistocene, especially during the most recent ice age. So that's why there are no deep peats. It's only a hypothesis based on some observations of our own, but it's just a hypothesis that requires further study. We are still receiving questions. Jonathan is asking, why do apparent densities in the soil in the studies gave us a result higher than 2 grams per cubic centimeter? The apparent densities of the soil on the wildlife studies? Well, I do not have idea of that because it depends a lot, and I would advise Jonathan to check that. It would depend on the horizon of the mangrove where this was obtained, because remember that most mangroves, this is not written in stone, but most of the mangroves, the black mangroves, Avicennia, have a population of different species of crabs from the Uca gender or the family. And these crabs, they run through the mud and they bring remains of plant litter. It can be a high productivity, and they put that into their homes, and they grind them, and they are constantly bringing mud and plant litter, and they are quite efficient. They are turning the soil upside down. And if you take a sample of sediment in a mangrove, in a black mangrove, in the first 20 centimeters, you're going to find an apparent density, because that's quite high, because the fiddler crabs are constantly removing and mixing the land and the soil. But if you go deeper, like 40 centimeters and beyond, and you get to the peat, to the roots of the black mangrove, you will find that the apparent density decreases to less than 1 gram per cubic centimeter. So the apparent density depends on the substrate. I wouldn't say soil, because it is difficult to define it as a soil, but it's a substrate, a coastline substrate, and it depends on the level of where the sample is being taken, and you can find apparent densities that are quite different from one another. So you would need to see where the sample was taken. In our experience, when you get to the peat layer, the apparent density decreases to less than 1 gram per cubic centimeter. We have even 0.4 grams. It's like a place in the Arctic. And also the red mangrove, as you can see in the image by Mr. Burto in Chiapas, the roots get deeper into the ground, and then we see peat on the surface, and it's really different. The soil is different below the soil of the red mangrove. It's completely different to the layers, the substrate layers below the black mangrove. In Tabasco, we have them, and they are quite deep. The soils are quite deep, more than 1 meter of depth, especially close to the river Tonalá. We are still receiving messages congratulating you on your presentation. Jesus is asking, what can you say about sites where some coasts are located based on the mangroves? Have you studied that? What coastal thing? Well, he's calling it armoring, like a barrier. Yes, I understand now. I get the question now. That's an excellent question, by the way. And it has a lot to do with things that we are analyzing in different parts of Mexico. I just want to remind you that you have 2 minutes, because you have another presentation at 2. Yes, the question is related to many of the things that we have seen in the Mecuacan Lagoon. We have seen it also in many other places in the national salt marshes, and many of the constructions, hotels, restaurants are done right by the coast, right next to it. And the environmentalists are saying we are not cutting the mangrove, we are only building on the vegetation beyond the limit of the mangrove. And yeah, that is true. Many developments are there. But what I hope I was able to show you with my charts in Bahia Magdalena, in a short period of time, in 50 years, the mangroves can move 10, 20, 30 meters or even more. In Bahia Magdalena, where the slope is quite small, the mangroves had gotten 100 meters inland. So if we put a concrete wall beyond the mangrove and we think that it will be fine, we will be facing a problem there, because perhaps those that are old like me won't be able to see it, but those that are young will remember about this 50 years from now, when the mangrove will get a terrible erosion, because those constructions live more than half a century. And currently, with this rate of sea level rise, 2-3 millimeters a year, we can see great changes in half a century. We have several questions, Doctor, and I would like to say that we will send them to you, and perhaps you could answer them. We have a final one by Mr. Tobilla. 150 meters, we see red mangrove and also Conocarpus erectus. These are in Cascadas de Reforma, this beautiful place, and that's where there's no salt. And you already answered because it's only about carbonates. Well, once again, we want to thank you for accepting the invitation to participate in this 5th Mexican Congress on mangroves. And we hope to see you again. We'll be in permanent touch with you, and we won't take any more of your time because we know that you're busy and you have another conference right now. Thank you once again, Dr. Escurra, and it was really nice to see you and to say hi to you. Thank you, Ophelia, and thank you to all of you for participating. It's been an honor to participate, and we have some pending questions there, but if you send them to me, I will gladly reflect and answer back with some ideas. Thank you.